tere, Reili, kas sa kuuled meid?
tere, kuulen.
Väga hea. Nii, aga nüüd, kuidas meil see ruumikaamera? Vaatame. Aga ühesõnaga ta praegu ütleb, et meil juba rekoodima hakata, aga me veel ei ütle okei, on ju talle. Ei taha praegu veel, võtate see recording nüüd maha. Meil ei ole mõtet praegu siin recordida midagi. Take a seat. We will then slowly start. First with my monologue, but you are happy to ask questions. And I will ask some questions later from you as well. Because in many cases it comes out that, yeah, I do my monologue, but you do your thoughts, do your own thing. So try to pay attention. I will ask some questions later on about the process. But yeah, very welcome to everyone here on spot. And we have more participants online from many different countries. So they are also all listening and would be great to hear the ideas proposed by you, but also several of them have came up with interesting solution ideas to those challenges. So, did we get this? Okay. So first, yes, I will take the first half an hour to tell you how we got here and what are the next steps so that you would understand, because it's quite different from the Horizon proposals, quite different from the usual startup things. So you get an idea how it will go. And then during the day, we will have 3 sessions of pitches of the solution ideas. The middle one is really long, but the first and last one's a little bit smaller. So let's try to pay attention. And the ones pitching, please really try to keep your 3 minutes so that we also have time for 1-2 questions. And I hope technically everything will work. And use the breaks for really networking. Maybe you want to join forces with some ideas. Maybe you can find some great team members for you and the cities and so forth. Try to talk to the people you'd like to, maybe whose idea you'd like to pilot. Okay, so we are in the Smart City Challenge round 5 already. This means that 4 rounds are already either going on or already done. And yes, we have the 2 winners, meaning the ones that need to do the hard job and really do the solutions. We have a decision in September. But yeah, I will tell you what's going to happen in between. The ones who just still don't know us, so we are the Finnish Center for Smart Cities. We have Research and Innovation Center launched by 2 universities, Aalto from Finland and Talte from Estonia. And we have really the ambition to develop 10 solutions that get implemented by at least 30 cities in the world or in Europe by 2030. At the moment, we have 6 solutions implemented in 7 cities. So we are already on the way, but still a long way to go to really reach our ambition. So the piloting program started in 2020. And yes, this financing period ends in 28. So all the pilots need to be done by the end of 28. But yeah, we combine, as you already have seen, the city challenges where we always start gathering them, and then the researchers and companies to propose solution ideas, develop them, and get these to the market. This is, yes, financed by the European Regional Development Fund and the Estonian state financing. And the goal is also to help the Finnish Center to become sustainable in long term. So we want to create solutions that become successful in real market, bring in real money, so that we can do more and more pilots and continue after the end of this financing period as well. And yes, we have then 15 million to carry out 13 pilot projects. And this is the money we are talking about at the moment. So we have already done, there is already a question from Norosema. Do you want to ask it quickly before we continue?
Sorry, my mistake, sorry.
Okay. Then it's okay. I put it, I guess, small and then it doesn't discharge. So yes, from 2020 to 23, we had rounds 1 and 2. There were 6 pilots done. 4 were the longer ones at that time. That meant 29 months. And 2 ones were just 18 months. So it was, now we are in year 25. So by now we can say that unfortunately one has failed by now, meaning that the pilot got done, but unfortunately the technical product is still not good enough to be on the market. And unfortunately also not the researchers are willing enough to cooperate and do the newer versions. But yeah, things like that happen. Two of the products have already earned money to us. Green Twins, that is a product called Herbarium.ai, and the Digi-Audit that is licensed to Finnect. So these have already brought money on board. We also have done a first sales deal for the urban well-being, the biggest sum so far, but the work starts from January. And the microgrids also has the goal to close the first sales in 2026. And we hope that also the autonomous vehicles become more popular, and hopefully we can sell that service at one point in time as well. But all those pilots solutions are available at our homepage, so you can check and see what they are, or if your city would need that. What we have learned from these first rounds and what we do differently. First is that we need to go international from day one. The first rounds mostly were done with Estonian cities, and unfortunately, some of the solutions are very well usable in Estonia, but to go to other markets very difficult because the infrastructure they rely on is in Estonia, but not in other countries. That's the reason we opened it up globally. So we gathered and are gathering challenges from all around the world, from the cities. And in each pilot, there needs to be one city from Estonia and one city from elsewhere. Always this, because it's Estonian money, that's the Estonian, we want to see impact here. That's the reason the Estonia is the must, but also, yes, some city from outside, so you think the international context. The other is the business side. As said, we want these solutions to be scalable, meaning you can sell it and someone is ready to pay for that. And we understood that we need to demand more from the teams, that you think about that already now. And we are also supporting you much more. For the finalists, we will offer training, we will offer one-to-one consultancy during the project. We also offer your business coach and trainings and so forth to help you really to think how that will be a business and a product. And the team or the partner you have as a commercialization partner, meaning a private partner, these are the ones that takes it to the market. You cannot say to us that, please take it to the market. We help you in all the ways, but we cannot do your business because that's very knowledge intensive, the things you do. We need the smart people in the teams to do the business. And the third one was that really now for the schedule, these pilots, real things that happen in the city, should be in the middle, not during the last months of the pilot. Because always in the pilot, you find out some things that didn't work. And you need to do the adaptations before getting to the market or before the cities can really implement it. So these are the changes that we have really done in the new phases. So 3 and 4 have done this way. We had 77 cities from 26 countries in these 2 rounds to propose the ideas and vote for these. From 2 rounds, we got 65 solution ideas. We have chosen 6 in both cases to the finals with whom we did the full proposals. And now we have selected and financed 5 new projects. The last one starts in January, the others are already running. So these are the ones at the moment going on. The 2 spots are there for you to be launched. As you see, it's not only Estonian cities. We have cities from Croatia, Ireland, Latvia, Czech Republic, Belgium, Finland. So in each of the pilots, there are also 1 or 2. 2 is minimum, but you're welcome to have more because you have more interesting setup then and more insights in reality. So as said, so for the projects, we want to have these 3 phases. In your case, when it's 24 months, because as we said, they have to be ready by the end of 28. So the first period, 6 months, short period, to do all the development, get everything ready for the pilot. Maybe you need to tender, you need to agree with the cities. and with the real estate developers, how really in practical terms you can do the pilot. And yeah, trust me, it takes much more longer than you think. You need to start very early to really see how it goes. Then the second phase is really running the pilot, analyzing the results, seeing what works, what doesn't, and also validating the business plan more and more, talking to more potential customers who really are the ones that are ready to pay the money for the solution. And then based on if this, like the pilot was successful enough, you had concrete hypotheses. This will work, bring this, bring that. Does it really work? And the second thing is, does the market give you the feedback that really there are companies or cities or people, whoever your customers' potential are, they are ready to pay. And then we give money for the last phase. And this is really preparing for commercialization, but also your partner cities and real estate developers to implement the thing. Because maybe they need to change their processes and so forth. So if they are happy with your product and the business model, then hopefully they will be your first customers. So in this round, we had these three kind of key fields that we were looking for challenges and then the solution ideas, the safe cities, the resilient cities, and happy cities. So we a little bit kind of limited the domains that we wanted to go. So in practical terms, how it has been, by the end of September, as you remember, we got 49 challenges that were proposed by 31 different cities from 13 different countries. Then we grouped them because some were similar, and then the cities had the opportunity to vote because we wanted to keep only the challenges that there is interest in Estonia, but also in some foreign countries. Thanks to that, which resulted in 25 challenges. We had 67 cities from 21 countries now voting and letting know what is important for them. And so we got 25 challenges that stayed in this round. Then was your task as the researchers and companies to propose solution ideas. And yes, we got a good number, much bigger than previous times, 47 ideas for 19 challenges. So 6 challenges, unfortunately, didn't get a solution proposal, but several got several, as you have probably looked at the homepage. I guess the maximum was 7 ideas per one challenge. And now we are here, like pitching those ideas. And then the next step is already in some time, but in reality, I have to say that is a very short time. Don't leave it to the last 2 weeks. If you are starting to look for cities like 2 weeks before February 27, quite probably you will lose. So in order to proceed, you will need 1 city from Estonia, 1 city from elsewhere as minimum to say that, yes, we are interested to pilot, and not only say yes, but also talk to you, give you feedback, discuss it with you, so that the next phase proposal you make already together with them. So that's an important task, to listen to them. So the projects will start from November 1 and then 24 months. So by the end of October 28, they should be done. Both projects will have the budget of about 840,000, quite a good sum. But in reality, when you start to go into details, then it's not a too big sum. So you need to think carefully what to focus on, whom you really need and whom you don't. The financing scheme may seem quite weird or not known to you, because in reality, this money is given to Taltech, so we cannot cascade it to any other juridical partners. This means that we cover all the costs directly. If you need to buy something for the piloting, we will do the tender, we will buy it. For all the people already employed, that is easy, they just get their salary. There's researchers from other universities and from cities, we can hire them and pay them salary. But we cannot give budget to a city or to another university. But this is already done in rounds 3 and 4, so we are hiring happily researchers from other countries. They can stay to work in Belgium or Ireland where they are already working. We just employ them and pay them salary. We are happy to cooperate with their universities, but we cannot give money to another university. That's written into this method. But yeah, we cover all the personnel, direct costs, travel costs, marketing costs that you need to have there. So for the researchers, why to participate, why are you here? So yes, one option is that you have done good research. Now it's an option to get it to the real life, to see it actually working and how it works. Gather additional data. If you get your solution running, you can gather the data also long after the pilot project if it stays used by the cities or by other companies. So you can use that data for your research. And also, I've seen it interesting that in most of the projects, I think even all, the teams are very interdisciplinary. So you get the experience to work with researchers from many different institutes, even different universities. That's challenging at the beginning. The terms you use are a little bit different, the understanding what the terms mean. So it's learning also from researchers from other universities and getting an interesting thing. Yes, and all your work will be covered 100%. This is the Horizon scheme that also this 25% of overhead is paid for the personnel and direct costs. Subcontracting, there is no overhead. So for the institutes, you need to give something to the central, as you know, but something stays also to you. So 25% in Taltech is okay. For the cities, yes, let's say you get a tailor-made product for free. We don't give you a separate budget, but we cover all the costs. So you can give your input, the researchers should listen to you, and the solution you will get is something new, and you can use it, and your insight is taken into account. Your people, if they are contributing and if it's okay for your city, we can hire them and cover their time. In some projects, the cities work in kind, meaning they don't ask salary. In some projects, they work for us. So it's up to you. But yeah, we can cover the traveling costs. We can cover all the direct costs related to do the piloting. If you need something really studied in your city that's connected, then this is probably your own financing, but that's then case by case. For the real estate developers, private campuses, you can also be, and you are very welcome to be, an additional partner. In reusing old buildings, we have already 2 of those. We have Untitled and Tallinna Sadam, who have joined in reality the pilot project. So we cannot cover the costs of the private or these campuses, but still the researchers do all the work for free. All the things for doing the pilot are covered. Just we cannot cover your salary or buy things for you. But the rest, all the other benefits you will still get. For the technology companies who now also have proposed quite many ideas, yeah, unfortunately, the same case that we cannot cover their costs or your costs. We cannot hire your people. But you can become the commercialization partner, meaning the work is done by researchers and you don't need to pay salary to them. You will get 2 reference clients, minimum you can have more during the things. So when the project ends, you can bring the product to the market and go further with that. So you get your product to a new level using the most valuable researchers you really need and get the references for your product. So the next task that you will do is this: by February 27, you need to do the initial pilot project proposals, 6 pages, so nothing difficult to write. I guess you can do it in a couple of hours, that's not, but you need to talk about this. The first thing, yes, the title, you already most of it have. Please don't use acronyms that mean nothing. Use the words that you could guess what the thing is about. And you can also add a longer version so that from the heading, one would understand what we are talking about. Duration is 24 months, nothing to do. For the main context, have one person who is the kind of research and development lead. Ideally, that should be from Taltech, but in some cases can be from other university. And then you need those minimum 2 cities. So basically, it's or if you have more cities or real estate companies or this commercialization company, so one contact per organization in the beginning. And contact also means email and phone. We don't ask the cities and real estate developers to send us the letter of the intent or something written, but we will call them when you propose and ask them, did you really agree? Or did they just write your name here? So have the contacts for us. Then the second is the first kind of main question that's already you have kind of answered, but now discussing with the city, bring out the specific things, because in many cases, those challenges were quite broad. Probably you don't solve all of it. So bring out the specific things that you can really influence with your solution. So tell about the specifics when you talk to the cities and find out what's really the issue, because in some cases they were very broad and vague. And then the solution, see that it matches. If there was such a problem, how does your solution really solve that? In some cases, we read the challenge and we need the solution and we don't get the connection in reality. So be very clear how your solution solves the problem and to what extent. Then probably the most new part, you also had already or something about the innovation commercialization, but now that goes a little bit deeper. So definitely think, what are the solutions already available? If you say you are the only one, we don't believe you. Always there is something, and our evaluators will find it out. So better find out what's there and tell how you are better. Probably you are, but if you don't tell and say you are the only one, then unfortunately you can't kind of explain it to us how you are better. Yeah, think who could possibly be your customers. Is it cities? Cities are difficult customers. If you think about private sectors, then who could be the ones that would be ready to pay money for that? Is it citizens? Is it transport companies? Is it real estate companies? Who are them? And also a little bit about initial ideas about the business model. Would you have a monthly subscription? Would you just do a consultancy fee? Whatever that can be, there are many possible options that are there. And discuss it definitely with your partners as well. And think also, usually there are kind of two options to go organizationally, is either some people from your team create a spin-off company. Do you have such people interested? Do you have someone in the team who has business experience? Maybe you can still find one. Or the other option is that you have this commercialization partner either on board already, or you kind of at least list some possible options whom you could license your product to. So think how you'd like to. You don't need to make the final decision, but you have to keep it in mind. What are the options? And then the impact. What's the concrete impact your solution could have to the people, to the cities, to the environment? And there is also the checklist in the end, like it was previously. That's for you to read. Feel free to delete it when you have read it and use all the 6 pages for your answers. Then, yes, some questions, probably you know some answers, some maybe not. Do you need researchers from TalTech in your team, or can you do just researchers from some foreign universities? Yes, you need minimum 2 researchers from TalTech in your team. So if you don't yet have the homepages give you the hints, either Finest or TalTech, and you can ask also us for some hints. Often ask these private companies who already want to be the commercialization partners, can I buy things from them? Can I buy services? Can I hire their people? Answer is no. If they want to be the commercialization partner, we cannot pay money to them. It has to come through open competition. If you want to come, sure, you can buy things from an open market for open tender, but not with related companies. So whichever company, but so you cannot prefer one company whom you have made an agreement with. By February 27th, you need those piloting companies. You cannot come without. So we will not evaluate these initial ideas, but the cities will, with saying, I want to join or I don't. So do the work started now, really, to convince the cities to have the meetings It's not enough that they say yes via email. Have a real meeting online and discuss with them. Get their feedback and talk about practicalities, how this pilot could really work, so that you understand. Who will own the IP? Finally, this either a spin-off or the commercialization company definitely will own it. But initially, that's our investment. So we cannot give this investment away just like that. So we will agree with you how we will initially license. And after 5 years of the end of the pilot project, we can give it to you. But again, we need to agree exactly which terms. That depends on the business plan and so forth. So far, we have managed to agree these things nicely with our spin-offs and also with the licensing company. And yes, who will take care of the business side, do the commercialization? It's not me, it's not my colleagues, whoever, it's your team. So find that you have in your team someone with business experience, or if you have researchers who are willing to do this, come out of their comfort zone, we can help, we can support and so forth, but you need to have the will to do it. Or then you will have this commercialization partner whom you work together and they will be the one. So the next steps for the researchers, yes, start with the cities. If you don't have the cities yet, try to contact the cities first that are the homepage that show the interest. You can also invite still cities who are not there. We also have today participating cities that are not yet in the process, so they may contact you. But yeah, try to get them on board and agree an online meeting to discuss the thing with them. So that's the first thing. Then the second thing, you don't need the team to be ready 100% by the end of February, but it has to be, we have to believe into the team. The PhDs and postdocs, you can hire them when the project starts, but you need to have the key researchers whom we believe in. You need to have someone who takes the lead on the business side, whom we believe in, and you need to have the city experts from the cities who are ready to work with you. And then, of course, you need to write together the 6 pages based on the discussions you had with the cities and send it to us. Send it on our template. Don't do your own templates. For cities, if you really like some idea and want to be the piloting partner, contact this research team, because otherwise maybe they don't contact you or contact some other city. And especially the ones that are new and that haven't shown the interest yet. All the contacts of researchers on the homepage, contact them and discuss if you can be the one to be piloted in. And from the city, then exactly, in some cases, these have been the project units or strategic planning units or smart city units. Now try to find from your city the experts that really understand and know this complete domain to work with the team. The ones that really know, that have the problem, that can give really smart insight of how it's really done. And yes, give honest feedback. Open up to the researchers, because the researchers don't know how the cities work. If you don't tell them, don't imagine that they will guess. Let's not assume. So the researchers can't assume they know how cities work, and cities can't assume that researchers know how we do things. They don't. They love their technology, but they don't know how you work on a daily basis. So what happens after February 27? Then there will be a team of us from the Finnish Center and team from the ministries who will then evaluate the proposals, and we will during March, and we will choose 4 to 6 proposals to the finals, because 2 will finals. It doesn't make to choose 20, because that's already quite a lot of work that we need to do there in the next phase. So what will Finnish evaluate? We will evaluate the business potential, your team that we should believe in, and the feeling that you have really listened to the cities and talked to them, that they are really on board, that we get the feeling from your applications. The ministries maybe look on more specific things on the fence. That's also always available, but read those things and bring those out, because when they start to evaluate, then they read if they can do the tick, if you really are thinking about Maybe you can't like address all of those things, but most you can, probably. So the finalists start the work from April. This means now compiling the full proposal. The full proposal, we don't have any limits, but don't try 100 pages, but usually it's around 30, 40 pages that we have seen, and plus the action plan and budget. So that's already quite intensive work. We are also covering their costs, depending on how many we choose, 16 to 20,000 euros. So it means salary plus one meeting in Estonia that you can bring also the foreign city here and the Estonian city to really have in-depth discussions with your city and really do the planning. And one person from the Finance comes to each team also to help you through this process, because our interest is to have the strongest proposals as possible. Then you have to, these have to be ready by August 24. Keep in mind there is summer in between. You have vacations, so it's not so long time as you imagine. Then in the September, there is already an international evaluation committee. There are business experts, there are academic experts, and there is this public sector experts. They will do the evaluation, give you the points, and then the steering committee of the Finance will make the final decision. That happens in September. Then you have 1 month to prepare for the launch, and November 1 is the launch date of the new proposals. So we are a little bit over the time. So these are the questions you can think about. Do you know the answers? I hope you know. If not, then you can come in the networking break to talk to me and okay, what was that? I hope you know most of the things. Unfortunately, I don't see if there are any questions online. Doesn't seem to be. Any quick questions before we start the pitching? All clear, or too complicated anyway. But okay, but I then give the word over to my colleague Sille, and we start to hear these interesting pitches. So you need to let's say that like normal drawing. Okay.
All right. Good morning also from my side. Just to give Külle a break a little bit throughout the day so that we don't destroy the voice completely. I'll help to moderate the following session. In this part, we had in total 6 different challenges from the cities, roughly 2 to 3 solution ideas then for each of the challenges. And let me try to keep the time so that we don't go too much over time and break into the lunch break. The first challenge that we had was the 3 pits for challenging urban conditions, thinking about how to support tree growth, manage strong rainfalls, still also consider the impact for the infrastructure. And the first idea was from had the name here, Giancarlo Fodera,
Do we have it online?
I am here.
Okay,
Senior
good.
Babbage, so
yes, I can also see you. Can we make the sound a bit louder?
Yeah, okay. You can share the slides and say, then we see if the voice is good enough.
So I just sent a request to share the slides. Maybe you can just accept that quickly. Works. All right.
Yeah, we can see your slides. Go ahead.
Can you still see it or?
Yes.
All right. Hello, my name is Semir Babajic. I'm one of the co-founders of TreeSense from Munich, Germany. And we help cities keep trees alive and functioning as climate infrastructure, especially in the sealed and constrained tree pits. Today, I want to show how we can support Milton Keynes and designing and testing better tree pits using real-time data from trees. So very shortly about TreeSense, we are a spin-off from Technical University of Munich, and we in general make tree sensors practicable. So we can help cities using different tree sensors in a practical sense. But let me maybe jump into the challenge that we are talking about. So urban trees are usually expected to cool streets, retain water, improve liability, but ultimately many tree pits do not support long-term tree health. And hence the root space and water access are limited to those trees. So they basically decline early, or roots start lifting the pavements and affecting infrastructure. Now, at TreeSense, we have developed a sensor that monitors the raw stress of trees. So TreeSense Pulse is a device as large as a mobile phone that minimally invasively is mounted directly on the tree in the tree crown and measures the internal water status in the xylem of the tree. The data is sent via LoRaWAN or Narrowband IoT to a cloud platform where staff sees a simple traffic light signal, and if needed, they can also take a look at the detailed curves for analyses. So because we measure the physiological response of the tree, not only the soil or the weather, we can also compare how different tree pit designs, substrates, and irrigation strategies basically perform based on tree reaction. And TreeSense Pulse is already in use in more than 140 locations, including London, Stockholm, and several major German and European cities. In a pilot with the city of Munich, for instance, we have equipped young trees with sensors and tested different irrigation strategies. And for one tree, we only irrigated when the sensor actually recommended it. Ultimately, we achieved the same vitality with up to 93% of fewer irrigations than initially planned. So that pilot project obviously showed us what the potential is, but to save water, labor, and costs while maintaining the tree health. But we also have strategic impacts, such as impacts on the tree pit design ultimately. So our ask is to co-design a pilot with Milton Keynes as a lead city. And for that, we propose to monitor a representative set of trees in different tree pit designs, some existing, some newly built, over 1 to 2 growing seasons. And with TreeSense Pulse, we can quantify stress days, recovery after heavy rain, irrigation needs, and early signs of infrastructure risk. And we also really invite the other cities in this challenge to join as replication partners so that the results are transferable across different countries, tree types, and also soil structures. Together with Teltech on the other side, our ambition is to link this sensor data with satellite-based indicators and machine learning so that insights from single monitored trees can be scaled to entire streets or districts, making Milton Keynes a reference case for climate resilient tree pits. I do have some more slides. I hope I was still in time. Please let me know if you have any questions about that.
Thank you, Samir. You used the whole 5 minutes slot, so we don't really have much time for questions. Maybe the only thing is that have you already started looking for the researchers also from the Taltech side, or are you mainly it's a call to anyone listening also today?
Yeah, that's so for me, it was my first call, but we are really keen to work with Taltech researchers for that, especially from the observation and geoinformatics sensors. Yeah. So we haven't talked to anyone yet, but please follow up on this with this presentation. I'm happy to send it out afterwards.
Cool. Thank you so much. And we'll surely also send all the contact details afterwards to the audience. Let's right away continue then with our next presenter. I think it's Muhammad from and talking about the city tree remote monitoring system. Do we have you here or online?
Yes, I'm online.
Can you also check if you can see share the screen?
Do you see my screen?
Not yet.
Oops.
Yeah, we
On my
see it.
side, I see that it's visible on my side, or I'm sharing
And
already.
it's visible here as well.
Interesting. It's not okay. It's here.
Mhm.
Mhm.
Can we somehow drag it there?
I think you will have to click on one of those tabs in the upper corner of the Zoom meeting. There are different tabs above me, maybe.
I'm already, I think, sharing my screen.
No, my tab it's fine actually. It's just on their side. It's not on the right screen.
Online,
where
everyone.
everyone is.
Thanks. Yes, yes.
Any technical kind who can say it?
Oh, we could
That's
turn
weird.
it there.
Where do you see it? It's in the chat window. No, it doesn't help. That's weird. But okay, we can't take time. Just most of the people are online, so tell the story and we can share your slides then later. Okay, go ahead.
Okay, all right. Thank you very much. Good morning, everyone. My name is Mohammed Mehtawalam. I'm a professor here at Tallinn Technical University and head of the research group Communication Systems. I'm working in Taltech about 10 years now. So we look at this particular problem from the specifics of passive irrigation, community-supported watering practices, reinforcing civic engagement, and long-term tree care. This is some of the screenshots of Milton Keynes City, where the actual problems has been identified in this challenge, and these are the specifics that we are interested to contribute. So let me clarify that we're not offering a full solution here, but a part of it, which is related to these aspects which are explicitly highlighted in the challenge. Existing tree pits solutions are widely used, and here are a number of different examples of different products which are being used in different cities. One of the limitations with some of these solutions is the cost element. These are usually difficult to deploy for every tree, these kind of systems, and therefore important to develop a scalable low-cost solution. And this is one of the, I think, aspects that is relevant for this challenge. And in addition to different products which are available and with coming also with their different shortcomings and so on, also different sensors which are available in the market today, also well presented earlier in the previous presentation. And if we look at communication aspects, how the data is collected, among other methods, there's also satellite-based systems being used as of now. So this is an illustration of the existing solutions and technologies which are in use. From our perspective, let's say we are interested to provide and extract the telemetry data of the trees and engage community and citizens into this in order to take care of the trees. So idea is to essentially develop an app which every citizen can use and link themselves to a particular tree to be taken care of. So whether it's a matter of watering or their continuous monitoring and growth. And so for this, we intend to deploy sensors and monitor them, and also give live feeds to the citizens, as well as we intend to develop an application where this monitoring can be tracked, and in this way all the citizens could also be engaged in taking care of the trees. So as I said, beginning, we are not offering a comprehensive solution here, but part of it, and certainly we're interested to collaborate with additional cities. But in case we haven't yet talked to you guys, but soon we'll be contacting. And in addition, also figuring out in Estonia which cities could be used. We have similar kind of stormwater issues in the flash floods, and these problems are in different cities quite specific. So it would be interesting to look at also how Estonian cities could overcome these problems, and we'll be helping here. For the commercialization partners, I think we definitely need explicitly some researchers in university or specific organization who can lead the marketing and business model development and all these things. And of course,
Thank you.
also willing to collaborate with the other company who was presenting earlier. Thank you so much. That's it from my side.
Thank you. Anybody have very burning question to Mohammed? I don't see a hand here at in Tallinn, and no questions in the chat. So thank you, Mohammed. And meanwhile, we can then go to the next challenge, which was around infrastructure for autonomous mobility. And there we also had two ideas. First up, then about digital traffic layer for autonomy, either Raivo, Mauro, or Mohsen.
Yeah.
Raivo,
Yeah.
please.
Okay. Yes, my name is Raivo Sell, professor of robotics in Tampere, and we are addressing challenge which was indicated as infrastructure for autonomous mobility. So the initial, I think it came from city of Tartu, so they have a specific problem with the traffic light mostly. But the general idea, so challenge is that how to bring the autonomous vehicles on the city streets so that they can interact with infrastructure, because we have infrastructure which is daily use, and these are designed for humans, but autonomous vehicles need a bit different communication layer, which is called vehicle to infrastructure. Our solution is based on the idea that all existing infrastructure can be updated in terms of software and hardware, so that we don't need to replace those. Of course, it needs some development, but also we want to aggregate the different inputs, not only from infrastructure, but maybe other sensors, including the cameras or inputs from the web services and so on. And on top of that, our solution would use AI-based reasoning, also the classification and structuring the data so that it can be unified for easier use for autonomous vehicles. It's also flexible, so that if there is a new devices coming into the system, this can be easily integrated. And yeah, there are some key keywords what already a bit explained. So these are also on this presentation. And the next slide. So the expected impact is that cities who are participating, of course, and the pilots are ready to, or they are more prepared for autonomous vehicles, so either shuttles or robotaxis or smaller vehicles, which ones needs to communicate with the traffic lights and other infrastructure elements. Yeah, it helps of course, reduce all this emissions and things which is connected to the deployments of electrical vehicles and autonomous vehicles, and also increases the safety on the roads. What we are seeking is that the pilot cities, of course, they need to have some kind of access to traffic infrastructure through the partners. Probably they don't handle this by their own usually, but also willing to authorize AV operations on the defined pilot area. That's quite crucial so that we can run the successful pilot. Additional team members, we also are not very good in commercial terms. So if there is a good partners helping to commercialize or productize this solution. So how to make money out of this. These are most expected one, but also there's like security and maybe the hardware design or security in IoT devices is something that would be interesting. That's pretty much it.
Thank you for also staying very much in time. We have a bit of time for questions. Any questions from here in Tallinn or also in the chat?
I'm around.
No questions? I have a question. Actually, when reading up the challenge, there was also the aspect of the goal being in the end to actually reduce the dependency on private cars. To what extent you're also thinking about going beyond the kind of technical development also to how do you actually engage the citizens in behavioral change and so forth?
If you are ready for autonomous vehicles, then it automatically you can offer better services. They are really coming on serving the commercial basis services. So those vehicles who are ready to do those deployments also have advantage to reduce the private car and then also make the traffic safer in the city. I know that Tartu wants to be in the first city that everything digitalized, so that it's not like on the area focused project, but actually city-wise, so that full cities ready for different kinds of AVs, not only public transport, but also there's robot taxis and delivery robots maybe and so on. So that's kind of more broad solutions, but also it should be probably more abstract so that other cities can take it over. But there are of course always differences.
Right, thank you. Then let's go to the second idea around the autonomous vehicles, and that was a scalable autonomous mobility infrastructure from Mohammed again, please.
Oh, fine. We see it. Something happened. Miracle.
Okay, so maybe it just was a matter of resharing it, stopping and resharing it. So that's good. Okay, so
Yeah, okay, good.
all right, thanks. So for this challenge, we are looking into again some specific aspects of the proposed challenge from the point of view of infrastructure, where it's been highlighted the issues related to outdated infrastructure and existing support to the protocol, specifically DSRC and CV2X support for autonomous vehicles. While the other aspect, which is specific to data and more precisely fragmented data and unreliable data and lack of resolution. So these are specifics of the challenge that we target, and as such is covering like a full scale of this challenge. In terms of proposed infrastructure, so I think we aim to look at from the point of view of offering integrated, scalable, multi-technology solutions. So we can't expect that we have a CV2X support everywhere available. So therefore, DSRC's support is also relevant and important. And so in this context, we consider a scalable solution where we can use the both cellular infrastructure as well as short-range infrastructure. And for these specific problems that has been highlighted from the machine-readable traffic lights, issues that today controllers are not directly able to transmit these messages to the vehicles, and this is where we aim to contribute to able to have a machine-readable traffic lights for the autonomous vehicles. And the aspect of the mobility data, so certainly when vehicles are connected and we try to bring this data through the infrastructure, so we aim to collect additional data, but also remove the gaps that exist in today's fragmented data sets. So both elements is essentially we aim to contribute and collect this data into the central server, and from where we can apply in the future as well different types of methods for improving the autonomous mobility. So our offer is we have been in discussion with City of Tartu, propose this challenge, and they have been in principle interested to work together on this ideas that we are presenting. And also we have been in discussion with the traffic light controller company and further discussing with them how we can be valuable from this solution that we develop. And of course, we are very much interested to expand beyond Estonia and look into other cities who would be interested on solving this challenge. As well as we are interested to have some commercialization partners who could develop this as a service. And so some ideas are here, but we are now in a good position to build it from here and discuss with cities and also some commercialization entities. Thanks a lot.
Thank you, Mohammed. All right, questions to Mohammed about that idea? Comments?
I have one question, maybe to both of those last presentations. So in your next phase, would you benefit only from cities like Tartu with that kind of full-scale adoption of that kind of still research project? Or would you also consider some kind of semi-closed environments, that kind of almost like districts that are built up to be that kind of test basis for autonomous vehicles to be included as that kind of optional or second piloting site? So basically, to put it more bluntly, are you looking for that kind of full-scale operating city as a partner, or rather that kind of test ground at this point?
Maybe we start with Mohammed and then I know.
I think we are looking at the cities because the problem that has been identified in this challenge is related to fragmented data, for instance, it meaning that cities already do have some data about the mobility and they would like to fill this plus get the additional data. And the additional infrastructure, which is currently limited, this is also like actual environment. So in that sense, at least the way we see it is actual city environment.
For the pilot, I think the semi-arrive is actually anyway the easier aspect. That's the reality that we cannot pilot in a full city, so that's not realistic. But the target is, or the solution should work in the end for the full city. For the terms of project partner and then the piloting is definitely a smaller area, probably a couple of or number of traffic lights and different sources of information. So that's how it will go.
Good. All right. Maybe you can also then continue chatting about it during the break and what maybe also consider joining forces or ideate together. We continue now with the third challenge around separate collection by waste by citizens. There we had a solution idea, and that was from Yuri Kubinets, please. Do we have you online? Yes, very good.
Hello. Do you see my presentation?
Yes, only if you could put it still on full screen.
Yeah. Do you see it?
Yes.
Okay, thank you very much. I'm not Yuri. I am a presenter. I am Sergei Pavlov from Virumaa College. It's a department of TalTech. It is situated in Kohtla-Järve and Innovation Center. So our solution is smart waste sorting container. Why? Because across Estonia and really across Europe, residents still struggle with correct waste sorting. At the same time, new Europe rules demand much higher quality separation, especially for bio-waste. But municipalities have almost no real-time visibility into what's happening and where containers and where people make mistakes. So huge problem, huge market. At TalTech Virumaa College, we are solving this in the smart waste sorting center container. So it's a modular intelligent container built on the Darbox field level monitoring platform, which was developed by Vidri before. It's like this, yeah, it is small, quite small. And we have the software too. We add AI assistant cameras, sensor and display and voice guidance so the system can recognize what a person is trying to throw away and guide them to sort it correctly in that exact moment.
If you're continuing also with the slides, because
of course, excuse me.
One.
And it's in briefly here in the slide. So if every mistake is logged, giving cities real-time data on user behavior and confusion points. So we suggest two different solutions, and it's like a non-automated solution. It's an assistant solution for existing bins, because we know we have in Kohtla-Järve, in Estonia, we have existing bins, so our solutions make them smarter. And automated solution, it's like we develop the new solution. It's from the mechanical point and from the assistant point. But the aim the same. We use AI and we use guiding solution for the people who don't know how to sort the waste. Right now, we are waiting for the partners, we pilot partners, ideally from hardcore in our Estonian municipality, plus 1 or 2 international cities interested in smart waste innovation. We are also seeking for RID and commercial partners and to help scale the solution. And of course, thank you for that. We are excited to build cleaner and smarter cities together. Thank you for your attention. So if you have questions, you can ask. Yeah.
Yes, okay. Indeed, we have a minute to spare for questions. Any questions from people online? If not, then of course continue also chatting later on in the chat, and even those people currently here, you can always also join the Zoom to continue chatting with Sergei and other online presenters. To also get back into track with the schedule, I'll continue right away with the next challenge. And that was around actually circular construction, focusing on the lack of accurate data about building parts. And there we had 2 ideas. First up, we have decentralized urban material mapping by Shahab. We have you online, yes. We cannot hear you though, if you're speaking.
Yes, yeah, I think I changed my mic. I think you can now hear me. Hi
Yes.
everyone, I'm Shahab, and I literally finished my PhD at Tärnov paper, but I have to defend as well. Yeah, so the idea is that as the problem said, we don't know what buildings are made of. They are old. The drawings are not found, whatever. And currently, as described also in the challenge pages, my computer hanged actually, so the slide doesn't load. I'm sorry, my computer hanged. So as mentioned, as a problem in the challenges, there are drones or other ways of tackling the solution, but they don't work because they are quite decentralized. You can see only facade or roof conditions, not everything. So the solution is that we start having a citizen-based scan economy in a way that we give incentives to people and they report the data to us. It can be citizens, delivery workers, handling or building the buildings, or companies working on the buildings, and fill everything in the database. Do you still hear me, or?
We can hear you, yes. You're
Oh,
a bit
great.
close. We can see the slides and hear you.
Yeah, because Zoom said that it's not responding. So the database will be filled with the data, and it will have also confidence measures, and I have a great idea how we calculate the confidence as well. since I'm running out of data, I think I go to the last. So the innovation is the economy itself and the tokenization and how to create incentive for everyone to fill in the database, how to say. And there are a lot of technical needs. We want to make it a gamified system, and people earn credits through the reports and giving the confidence points to it. You may scan and read a bit more about the idea. It has a lot of small stuff that together become a bit complex, so maybe it's hard to present exactly in 3 minutes with the laggy Zoom that I got exactly after sharing. But I'm ready to answer questions, and also you can scan and read a bit about it and contact me if you want to join the pilot as well.
Thank you, Shahab. Any questions to him about drone-based scanning and the solution idea? I don't see hands here, nor questions in the chat. I have a question actually about one part of the challenge was integration with existing databases and other kind of city planning platforms. What's the idea? What's your idea regarding that and how to plan to work on it?
The idea is the main idea is the economics. So the research will be the economy of the incentives. Plus that we will have also open database that can be accessed with the API, both syncing data with the current available databases, but also read data from them. But the main plan is to.
All right. Since we dropped or lost Shahab, at least in terms of connection, but anyway, the time is also up. So let's continue also engaging with his idea afterwards. We continue right away with the second idea in this challenge, and the word goes back to Mohammed. You've been very fruitful with proposing ideas, so we have a third presentation. Please.
Well, yeah, thanks to you guys, I managed to get these slots before I get into the plane. So thanks a lot for managing all these straight up. Yes, and indeed, we have been interesting on quite a lot of multidisciplinary topics in communication systems research group and working on different EU projects in the background. Specific to this challenge, I think the interest, I can first highlight that what specifics we are interested in. The challenge which has been highlighted is definitely interesting and relevant in the sense to enhance the information or data about the types, quantities, and conditions of building materials so that we can make right decisions about the renovation of the building and precisely facade of the buildings. And existing several limitations which has been highlighted in this challenge, we are well aligned with the city of Rotterdam on these challenges. In terms of what we are interested in contributing here is related to accurate aerial scanning and more precisely able to collect ultra high definition cameras on the drones and able to collect quality data out of these scanning. Currently, it's very limited, and it has been like rather limited in research as well. So some works exist on it, but still, as such, this has been like relatively new area. So acquiring 360-degree exterior scans is quite tricky and complicated, but I think this is where we would be very much interested to contribute. And this is the flow, so able to collect the data and apply AI ML techniques to be able to then develop the traceability of the materials and then able to bring this data into building information models. Or also exposed to make the decisions about the renovation of the buildings and materials more precisely. So these are different aspects that we are interested to contribute. Then in terms of impact of this research, so currently the inspections are quite costly, and it takes about quite a lot of effort as well. So aim is to do it aerially with the drones and able to reduce these inspection costs to 40 and 50%. Also have more safer inspections rather than done it in a manual way or through these linear construction models. And by doing so, we could able to essentially help making these decisions about circular reuse or the demolition waste or reusing of the construction elements more efficiently. And then the next step is to also city level benefits goes to seamless integration into the building information models. And that's where I think that it's some collaboration what we are seeking also with the specifics of the civil engineering department. In terms of our ask to the cities, so we made initial contacts with the city of Rotterdam, who originally proposed this challenge, and I think that it is possible to engage pilot cities from Estonia on this as well. And we are very much going to look beyond as well, I believe, to have additional cities who could be interested in solving this challenge, and always seeking a commercialization partner who could be interested to commercialize these solutions. This is in all my pitches I explicitly requested, because this is something we would like to have a dedicated partner dealing with this. So that's all from me. Thank you so much. If there are questions, I'll happy to answer.
Thank you. Any questions? Seems not, and all the questions in the chat are related to the process, which I'm sure my colleague can answer meanwhile. But thank you, Mohammed. We'll then, just encourage everyone to reach out if they have further ideas for collaboration or also questions to you. We continue then from the circular economy and construction to energy, and there we have 3 ideas. This is about the first one is around resilient urban energy hub from Sergey. Do we have you online or here?
Yes, I am here.
We don't see your slides yet with your. You're sharing already. Okay, something's coming up. Good. If you can also put it on full screen, and then you have 3 minutes.
At first, my name is Sergey Rushkin, Taltech, Viruma College, Virik Center, and we offer resilient urban energy hub idea. At first, challenges facing cities. Ukraine critical services must operate during war, blackouts, and attacks. Cities in Eastern Europe, aging infrastructure, industrial transformation, increasing geopolitical and energy security risks. Cities in Europe are faced with rising energy prices and the need to implement microgrids and energy communities. Cities around the world facing power cuts caused by natural disaster. Our response, the Resilience Urban Energy Hub, a real physical prototype of an integrated technical solution based on a microgrid architecture. Our solution is a modular, scalable microgrid structured like a cellular network. There is no single point of failure in the power core. Supports peak shaving, island mode, grid support, and integrated load management. At the center is AI-based EMC. Can be installed in reinforced rooms or can be mobile. Our solution delivers 4D resilience, chemical resilience, network resilience, cyber physical verification, and technological components from Europe and friendly countries. City benefits. The solution can reduce grid dependence, cut carbon dioxide emissions, and enable infrastructure operation in island mode. Creates a platform for study, research, and development. A prototype for operator training and transferable blueprint that cities can operate after the pilot. Supports modernizing urban infrastructure, increasing city empowerment. Our research and development focus: wartime energy resilience insights from Ukraine, a modular cellular microgrid architecture, fire-safe ESS, AI optimization, reinforced protective structures, a legal and regulatory framework, an educational and demonstration center. In addition, we will study the possibility of using hydrogen for energy storage. Our team have an experience in the development and operation systems for critical infrastructure, and we have relationships with equipment developers and manufacturers. We will rely on the unique resources created in Kohtla-Järve demonstration physics lab and virtual lab. We invite Vinnytsia, Kohtla-Järve, and other cities like Narva, Valga, Lviv to join us. We also invite research and development partners, commercial partners to collaborate on scaling the solution across Europe and beyond. Our goal: the safest, smartest, and most resilient urban energy hub standard for critical infrastructure, telecom, rural electrification, transport, and data center. Thank you. We look forward to build this future together.
Thank you. Any quick questions to Sergey? If not, then I don't see it. It's interesting. There's a lag in this computer. Let's see quickly if there's a question regarding that. Not really. So then we continue right away with the next presentation. And if you have follow-up questions to Sergey, you can reach out to him. The next one is Resiliency-Based Urban Grid Planning from Vahur Mask. Please, you have 3 minutes. Yeah, I see it.
So greetings everyone, I'm Vahur Mask, and with my colleague Tarmo Brõtko, we are addressing the challenge stable energy systems in crises.
I think they don't see it online. Just a second.
Yeah, okay, thank you. And challenge itself comes from that cities have limited means to prepare their energy systems for crises, but actually they have and operate electric power systems such as street lighting. And cities can invest in redundant electricity infrastructure, but they lack optimal planning and knowledge how to do it. So in here, we come into the help with the GIS-based planning tool that allows municipalities to design and optimize a parallel municipality-owned grid, which is capable of reconfiguration and energy islanding. So this tool is innovative in 4 main ways: municipal alternate grid focus, so to empower the cities and especially communities to allow community energy sharing in communities, therefore reducing emissions. Secondly, integrated geoenergy optimization. We can take into account existing infrastructure like street lighting, distribution system. We can take into account the consumption of public buildings such as hospitals, schools, and so on. And also we can make proposals for renewable energy generation sites and storage. And resilience and crisis-driven planning. This means that during blackouts, if the main grid is down, this small municipality-owned grid can sustain itself. and governance aware, so we can model the shared ownership and operation rules between city and TSO, the transmission system operator. We are open to cooperation. We are proposing this solution to Vinnytsia, who is the main, proposed this challenge, and also one Estonian city. The list is not final, so if representatives from municipalities here seem like some interest in this, then feel free to join. And we have in microgrids and metrology research group, we have competencies about planning, optimization, and framework for deployment. But we are seeking other competencies. If you are expert in spatial analytics and software development, then you're very welcome to our project. So thank you.
Thank you for good and in time presentation. Any questions to Vahur? Doesn't seem so. My question. Yes.
Thank you very much for this suggestion. Actually, so for mentioning Vinnytsia, we are really actually so aware of participating, and we do hope actually to implement our idea.
The sound is quite poor quality, as I understood that the implementation of this idea was the question.
Probably they said that they were very much interested to implement the idea and discuss it with you. Okay.
From the city of Vinnytsia. My question though is in terms of the commercialization, have you already started thinking about the plan for this one? If you are also interested in additional partners regarding that part, or?
Yeah, we are very welcoming commercialization partners here. Also, we listed some Estonian companies who are dealing with the GIS tools, and also other from outside Estonia are very welcome to get on board. But yeah, we haven't discussed these business ideas yet or business models.
Good. Well, you have several months to continue thinking about it.
Thank you.
Thank you, Vahur. The last one regarding energy topic is HydroTwin energy islands for cities, and if I'm not mistaken, then we have Serkan.
Yes, I'm here and I will share my presentation.
Yes.
Okay, you all see, this is us. Hello everyone, it's Serkan from Taltech. I'm a professor in Green Marine Systems. And the challenge we are addressing is the stable energy system in crisis. So the global carbon emission is increasing and renewables are the solid solution. They have also some issues that to ensure a stable energy system in crisis, you need to focus on three important pillars: sustainability, reliability, and stability. If you think there is an energy crisis, maybe renewable might be not enough. So what we are proposing is solution is we can call it fit to place energy governance model. That means it's require a locally produced store green hydrogen from renewables. And I also summarize the impact that gives the impedance independence and converting hydrogen to electric form whenever it's needed. So that's the meeting with the energy demand. Internet of Things based continuous performance monitoring and emission monitoring will help the public awareness, and the machine learning based energy management system will improve the efficiency and improve the green economic growth and new investment and new local jobs. So remember, this is all locally solution. And this is inspired by my current project, just finished Innovate UK project. And this is we built everything on a vessel, used the solar panel to generate hydrogen, and the hydrogen use electrolyzer, pump into the hydrogen tanks, and use internal combustion engine to charge batteries and then power the like heating system or electrical system. We monitor using a grid network. So basically, the smart monitoring help us to improve our operation condition. As you see, the blue lines are showing how the power lines connected. Of course, we can directly charge the batteries using the renewable, but during the, let's say, winter or energy crisis, stored hydrogen will support. And while we are keeping net zero, so there will be no carbon emission. And this system is relatively much cheaper than people argue with the fuel cell, for instance. And we already contacted several piloting cities, and we have some requirements from them. Cities are mainly Estonian, Finland, and Ukrainians. And we look at the geographically how they are and what is their natural resources we can use. We can generate hydrogen from water. So we will need to communicate with the cities, governors regarding their existing infrastructure and the geographic and climate characteristic, and also what is their regulatory requirements, because this is gonna be bespoke solution. Every city has different, and also engagement with local community is important because we are looking with the holistic approach. So this is all over what we are proposing, and I'm happy to hear questions. And yeah, excited to show this case for the cities in crisis, and this will definitely encourage more green economic growth and then bring new job opportunities. And yes, happy to have questions.
Thank you. Any questions to Serkan?
So thank you for your suggestion, actually, Kiso, and for the meeting that we have already had with you that is really actual for our city, so Vinnytsia, Ukraine.
Yeah, yes. So we actually, the first city we check is the Ukraine. You have fantastic water source there, and then and you have this river, and this system can be floatable even. This is how we first design and built on a floating construction actually. So this gonna be independent, no cable, long cable requirement, and I think whenever the energy demand is required, this will help. And it's scalable as well. Obviously, this is the best economic benefit. So basically, depend on the requirement, we can scale everything you are seeing here. And because it's gonna be open source, publicly monitored, everything, all the demand of energy and how much we generate hydrogen or use, that means we can have the future-proof solution. So, and
unfortunately, we need to continue at the moment.
Absolutely. Thank you very much. Thank you very much.
Good to see already Vinnytsia on board, and also encourage again with all the three ideas to also consider whether there's rational to also join forces for this one if you find it interesting.
Absolutely.
There's one more challenge with three pitches, and that goes to managing urban heat islands. The first one is for urban climate sprint model with Petri Koskinen. Do we have you online?
Hello, it's Juha Kangasloma. I'm presenting instead of Petri.
Good. Then please share your screen. You have 3 minutes.
Okay,
Yes.
thank you.
If you could put it on full screen, that would be best. Thank you.
Yeah, okay. So thanks. I'm Juha Kangasloma from the University of Helsinki, and we present the urban climate sprint model. So heat stress causes roughly 500,000 excess deaths yearly, and cities are at the center of this problem. And the issue is that urban heat is not distributed equally, but it can change dramatically from street to street. So today, cities are making multi-million euro cooling investments based on coarse data, averages, and models that don't really capture what people actually experience at the street level. At the same time, most of the urban land is privately owned, and there is currently no scalable way to involve private owners in heat mitigation in a structured and data-driven way. So we have a big problem that we are trying to solve partially blindly. So in our solution, we turn urban heat.
It seems that the slides are not changing for us if you're changing them.
Okay.
You could maybe reshare the screen. There we go. Now
You see the slides now?
Yes.
Okay, well, let's go with this. So then in our solution, we turn urban heat from a hidden risk into a measurable, fixable problem. So we combine two things. First, we have mobile street-level heat sensing, which measures the heat stress people actually experience. So not just air temperature, but also solar radiation, shading, humidity, and wind. And second, temporary mobile green, blue, gray infrastructure solutions, things like trees, shading, water, and reflective surfaces that can be deployed quickly. And this means that cities don't need to guess anymore, so they can measure the hotspots, test different cooling solutions, and test what actually works before committing into permanent investments. So we package this into what we call the urban climate sprint model, which is a fast, reliable, repeatable 30 to 60-day cycle, and it works like this. So first, cities select a target area that's experiencing excessive heat stress, and then second, the researchers can measure the experienced heat at a street level and model the different cooling scenarios, and then after that, together with the city and local and private sector stakeholders, we co-design a targeted solution. Now then we install it temporarily and do the measurement again, and then validate the real impact of the solution. And then finally, once we know what works, we can scale this into permanent and validated city upgrades. So instead of slow planning, we move from a problem to a verified solution in weeks and not in years. So what we offer is a fundamentally safer and smarter way to cool cities. It's fast, scalable, and scientifically validated. And the most importantly, it lowers both the financial and political risk of investments because decisions are based on measured real-world impact and not assumptions. So what we are looking for our project are cities to co-develop, pilot, and validate the urban climate sprint model. And then for our project team, we are looking for team members to model the experienced heat stress and develop the adaptive urban design concept. And then finally, we need team members to develop this project into a new scalable spin-out for end-to-end climate resilience services for cities. Thank you.
Thank you, Juha. Any questions to you about this idea? Comments? I don't see questions nor comments also in the chat. Maybe one question from my side is just in terms of the data gathering, and if there's any kind of preconditions that you see for the cities, meaning that they've already have certain type of mapping done that you could engage in the first part where you actually start to map the heat in a way in this selected area. Or is it, let's say, applicable to any kinds of cities?
Yeah, we can utilize any existing data, but then we have also a mobile system that we can really easily deploy anywhere in the city or anywhere in Europe. So we can really go for the locations where people move and where we expect the most heat stress. So I think both work.
Good. Well, good luck in the further development of the idea. We continue then with the second idea in this challenge, and that is collaborative climate resilience model from Karolina Orcholska. Do we have Karolina also online?
Yes, I'm here. Hello.
Hi.
It should work now. Yeah, I hope you can see my presentation. So hello, everyone. It's good to be here, even though online. My name is Karolina Orcholska. I am a sustainable urban mobility and urban policy consultant. And today I would like to introduce a practical approach to climate resilience in complex mixed ownership district. So in the challenge proposed by Warsaw, because Warsaw is already in the team, this is the challenge that many other European cities deal with. The climate vulnerability, such as like heat stress, stormwater runoff, noise, limited shade, this all appears across a fragmented urban environment. And some risks are on public land, but many emerge around private buildings, commercial areas, construction sites, and logistic roads. And this makes climate adaptation difficult, not because we do not we have lack of ideas, but the problem is that we have lack of structured way for public and private actors to work together. That's the main issue. And right now, cooperation exists, but it is informal or inconsistent and not scalable. So there is no stable governance model, no shared tools, and no clear path for private partners to become like co-actors instead of passive observers. So the real challenge is not only the environmental risks themselves, but actually the governance vacuum around them. And what is the solution? To respond to this, we are proposing the collaborative climate resilience model, which is a governance-first solution supported by simple data and fast, tangible interventions. And it has three connected components. First, this is governance framework. This is the heart of the model, and it clarifies roles, responsibilities, communication, and decision-making across city departments, property owners, developers, and businesses. And it creates continuity, not one of cooperation, because it gives private partners, a stable structure to participate, invest, and innovate. Then the light digital environment. So this is not a digital twin, just to make it clear. It's realistic modular tool that will help to make priorities or to do the list of risks, which are heat, runoff, noise, and others. And that will allow the city and private actors to see hotspots, but also compare scenarios and build shared understanding, let's say. And this is the purpose is to support decisions, not replace them. So it's it should help to cooperate between public and private sector, and it is simple enough to build within 24 months. And the third ingredient is a micropilot toolkit. And the model includes a set of small, low-risk interventions that can be co-created with local stakeholders. And this may include tactical shading or cooling spots, greenering, or any other noise buffering, micro logistic improvements. And by testing several small actions, early partners build trust, capacity, and momentum. And the city gains evidence that it works, that everything that they do or things that they are trying to do together with private side can work. And what we are asking for, together with Warsaw, we are looking for other cities working with mixed public-private districts to pilot this approach. Don't be afraid that Warsaw is a big city, but we are working within one district. That makes it like the small area at the beginning, and it will help to scale it later on. So
unfortunately, we need to move on. So maybe you can wrap it up with a sentence.
Okay, just we are looking for the city, another city, Estonian cities. We don't have researchers yet, so we are open to cooperate. And just the final, in short, this is a practical governance-first model for co-creating climate resilience in mixed ownership districts. And this will be supported by simple digital tools and fast micropilots. So that's all from my side. Thank you.
Thank you, Carolina. And so if you have any comments or questions, please do reach out to Carolina for this idea. The last one in this whole morning session is on mitigating urban heat islands in Europe with Levent Kugen. I hope I pronounced your name correctly. Do we have you online?
Yes, very well. Thank you very much. Share my screen. I hope you can see all my screen?
Yes.
It's okay. Great. Thank you. Thank you very much. Yeah, I hope. Yeah. Okay. Yeah. Thank you very much, first of all, for giving us this opportunity. We are new in the Finest community, so it seems to be a great opportunity to bring together cities and solution providers. So I'm representing here actually a group of partners. So I'm Levent Kurgen, CEO of Kentiu, a startup from France, and representing here a group of other innovative startups, Latitude 40 from Italy and RealSim from Ireland. Actually, we are indeed responding to the challenge of urban heat islands, which is, as you know, it's a difference of temperature, in particular in the nighttime, in the urban areas and the rural areas because of the urbanization effects, let's say. And it's an important one because the over of 4% of summer mortalities in Europe is actually attributable to urban heat islands, which is a very important number. And with some simple measures like increasing tree cover in cities by 30%, this could reduce the temperature of those areas in 1.3 centigrades, which would prevent like 1/3 of the premature deaths, which is huge. Other challenges actually that cities are encountering is indeed the lack of modeling the impact of city actions, like new construction projects, public spaces, or urban planning policies to those phenomena, urban heat islands, but also daytime comfort or CO2 emissions. And so the urban planners, they don't have tools to be able to make informed decisions. And in addition, cities are not aware of the danger and the impact of all these projects in those climate indicators. So what we are proposing is indeed an overall decision-making tool for urban heat island mitigation, a decision support tool that would enable indeed urban planners and technicians to better understand the urban heat island phenomenon. Also, this is a multi-stakeholder environment, facilitating the stakeholder engagement, the internal dialogue with the city, and also with in particular with the citizens. Indeed, promoting also awareness and capacity building based on this informed decision making for both management and technical personals. And we by ensuring for sure that the solution is scientifically valid, our team is composed of many researchers, PhDs in the team, that we ensure that everything is scientifically valid and interoperable, in particular with the city's IT systems, which is an important requirement. So the basic idea is indeed to integrate different data sources from satellites, from urban planning information, IoT sensors that may be deployed, some important points of interest in the city to have some particular focus on those areas, and then making this data integration, the advanced data analytics, machine learning, and AI to be able to calculate a variety of climate-related indicators, such as imperviousness, greenery, carbon storage, urban heat island indexes, and physiological equivalent temperature by combining all those data sources. And on top of that, providing a visualization tool, a decision-making support tool, including a 3D digital twin, so that the urban planners can see the effect of all those projects' actions on those phenomena. Basically, you have a warehouse like what you see there. You want to transform it into a park. For example, what would be the impact of this transformation to those indicators? And this is based on a tool that would provide all the insights necessary, monitoring of those KPIs, objectives, comparing before and after scenarios that would allow to make informed decisions. This is the team, as I mentioned, award-winning teams, innovative startups from France, Italy, and Ireland, having different complementary roles. Kentiu as a lead partner and data integration analysis part, Latitude, which is more on the satellite data analysis and
Should also
simulation.
continue at the moment, so maybe you can wrap it up with your final
Okay.
sentence.
This is my last slide. So we are indeed interested in two main additional partners, pilot cities. We have seen that there's Warsaw City plus other cities have interest in that topic. So we would be happy we don't start from zero. So we have some existing things, but still needs for adaptation to the pilots, and also researchers from Finance Center, urban climate modeling, simulation, data science, AI for environmental forecasting, and domain expertise in urban sustainability and resilience would be interesting profiles for us. Thank you very much for your attention.
Thank you, Levent. And as with all the previous ones, if anybody has questions or comments and wants to reach out, then please do reach out. Maybe as a final word from my side, it's interesting to also see everyone who has presented several ideas within one challenge, that you're also pointing out different nuances about the challenge. So it's obviously also not straight off that there's only one very clear one. You may also focus on different parts of it. So do continue also interviewing those cities to actually understand, as Külle already mentioned, not covering every part, but looking at a solution that you can really package and then later on also scale to other cities. That's it from my side. Maybe Külle wants to say something before we go to lunch.
Yeah, we will be back at 15:15. Let's try to be precise, but really reach out to the cities talk to the researchers, and start to think what the real thing will be. And if there were several ideas, then really see if it makes sense to merge the forces, but maybe not, because it's a short thing. Okay, thank you. Let's enjoy the lunch.
Happy I come now and not right before the presentation.
Kus te linnas kodus? Okei.
Ja see tegelikult migratsioonivaldkonnas vaatasin kiirelt, et tegelikult üks kaua, aga nagu ühes kavas ma leidsin ühe sõna, mis ei liikunud, arengukava. Et ma mõtlesin, et see tõesti on nii palju, et need on kuni aastani 2025 ja panen ka tööle. Neid on väga erinevad, kohalikke ka ju, aga lihtsalt nagu niimoodi suured.
Suured eelmises koalitsioonil.
Aga näiteks praegu on rõõmnõu kooskõlastamisringil on uue
Very nice. We also record it so you can listen to it later. So the first is about rain harvesting in the city, and we will start with that. And luckily we have Laura here, so I will share your slides and then you can start. This one, yeah? Okay. Okay, your 3 minutes. Go ahead.
Hi, I'm Nora Amrasla. I'm here presenting our proposal, which we elaborated together with 2 startups. One is Onscape with Maria Lisa Sone, in case you have any questions later on, and Hannah Fabricius from Herbarium AI. Our solution is tackling the question, how can we harvest rainwater, but also how can we prevent urban flooding? Nowadays, cities are increasingly facing more extreme weather events, which are causing floodings, but existing tools today don't integrate hydrology, ecology, and design for the urban environment. So we propose a tool which is integrating nature-based solutions with hydrology and also urban design. And in the long term, it would be ideal to also include monitoring capabilities. How would this solution work in 5 quick steps? So the first step we would see as a data collection and preparation step, where we build a spatiotemporal baseline connecting existing city data sets, and if existing, also digital twins, including the terrain, building, land use, soils, drainage networks, existing green blue infrastructures, and also the climatic data. And then link for the nature-based solutions, for each microsite, the local conditions, such as the moisture regime, soil, the shading, the salinity, existing vegetation, together with Onscape's already existing library on plants to find the perfectly suitable plants for those local sites. As the second steps, we would do a status quo analysis as a rainwater runoff analysis. So we would be using the prepared baseline and then for the system to analyze the microtopology, the flow paths, and the runs of the rainfall water to show where water currently in the real city or in a proposed city or a new district would flow and also overload road infrastructure. As a third step, we would then have the main tool, which is from our side the most interesting, where users, for example, urban planners and designers can then use it as an interface to draw and adapt, as well as configure alternative nature-based solution layouts and species mixes directly on the map or in a 3D model, and then rerun simulations, for example, with average rain with HQ30 or HQ100 to compare how well each scenario reduces runoff, flooding, and if applicable, also how much water can be captured through these nature-based solutions. The fourth step would then include the realization and the implementation in the city, and also how to implement or how to cover this nature-based solutions or how to transfer it to the existing city models of the cities. And in the fifth step, we would then look on how to monitor, maintain, and adapt those green infrastructures to those nature-based solutions over time, using, for example, sensor networks. And so we're working already with Onscape and Herbarium. I will not go too much into those companies as we're in limited time. Currently, we already have, me included, 3 or 4, depends where we count Hannah to Herbarium or Finnish Center researchers from Caltech. We already had a call with some cities for to discuss potential interests. Our next steps will then be go deeper in the discussion with various cities. If there are any cities listening who would be interested in joining, please reach out. We are very open to also expand the list of interested cities, because the next step is quite crucial to see what data do the cities already have and how could our solution be implemented in these cities. We already have quite some competencies within the team, but we would also be happy to also get further experts, for example, in rainwater hydrological simulations. Also, if there's somebody interested in joining the team with a big expertise on nature-based solutions. And as a lot of other teams, we're also looking for IT developers. So yeah, that's in a nutshell. Thank you.
Thank you, Laura. Any quick questions? Not at this point, then yes, thank you. And I will stop sharing.
I have a question, Külle.
Yeah, go ahead.
Thank you, Laura. I couldn't see the slides. Laureana Sapienza, City of Castenaso. We are really interested in your solution. I have a question about the data that the municipalities are required to have. My question is, do the municipalities, but I can't see the slides, so forgive me if I'm saying something not useful. Do the municipalities should have the data, already have the data, or could be a part of the piloting to provide the data for the solutions?
Ideally, the cities would already have the data by the start of the piloting, but as the piloting will start only around about 11 months, we would be eager in collecting the data with the cities already before the real piloting starts, because then if we only start with the data collection and we only have 2 years, I'm afraid there might be too many challenges. However, we are looking into ways how to collect the data, also using remote sensing technologies. So it's not a problem if the city does not yet have all the data, but this is definitely something we would like to address before the real piloting starts. But it's not the,
Maybe not.
Yeah, please just, we will, I stop talking. Oh, did you answer your question, Laureana?
Okay, now it's okay. Okay, then I think now we go to the intelligent management of sewer and stormwater networks, and we have a proposal. I think Ivaranus, are you online?
Yes, I am.
Yes, so feel free to share the screen and stuff.
Should I share my own slides?
Yeah, you can, then it's easier. You can, click.
Yeah. Okay.
It's coming. Yes, all nice. You can start.
Okay, thank you. So my name is Ivar Annus, and I'm a professor in urban water systems in TalTech. So today I'm going to briefly describe our idea. So it is related with different challenges, intelligent management of sewer and stormwater networks, but at the same time, sustainable drainage systems, data-driven decision support systems for urban water systems, and so on. So I think maybe you have already heard about the challenges. Of course, we have changing climate, we have aging infrastructure, we have stricter environmental rules, changing urban environment, and so on. So we need to rethink that how we operate and manage our water systems in urban environment as well. So, for example, studies in the USA have pointed out that if we don't do anything, then we need probably to increase the investment needs into urban water systems 4 to 10 times. And the studies in Estonia have revealed that this would probably increase the water tariffs, for example, in Estonia 3 to 4 times. So we need to change something. So our objectives is to provide this kind of proactive asset management for urban water systems to maintain the high level of service that we have at the moment, at least in this part of the world. And for that, we will develop new sensor technologies to transfer the management of those water systems from reactive to proactive asset management. We are proposing to use robots to develop and use robots that collect data in the places that it's hard or even impossible to collect it at the moment. We will use robots to place sensors to the places where it is impossible to place them at the moment. And we will use the new generated data to couple it with the existing GIS systems of the municipalities or water utilities to turn those into decision support systems to help the engineers to decide when, where, and what to do more or less. So how we will do it, as I mentioned already, we will develop new robots that will inspect our pipelines. So this will go from traditional CCTV to near real-time data acquisition. We will use robots to place sensors to different places where it is needed, not only possible, to get a better overview of the system status in those critical points. And we will develop this new integrated asset management system on top of this new data that includes 3 different modules. First, you need to have your digital twins up to date. So we will have more data to calibrate and validate the models, considering the changing conditions, for example, sedimentation buildup or infiltration or some inflows that we don't know about. We will develop a data-driven asset management model, which will give the municipalities an overview what and when to repair or reconstruct. So it is more database, not only your gut feeling. And we will build a scenario builder to understand the different uncertainties in the system as well, and then to be more proactive towards those uncertainties. So the expected impact would be more or less that the inspection rates will go up from 2%, which is currently, to 15 to 20% per year, which means that we can inspect our system within 5 to 7 years, not in 50 years at the moment. Similar studies have showed that we can save costs up to 25%, and we can provide more accurate considerations of what is happening actually in our systems, and then maintain and operate them more efficiently as well. So what are we ready to do at the moment? We have already a high-fidelity digital twin or model of the systems available in Tallinn. We have a collaboration agreement in place with them for the sensor placement for using robots in their system as well. So for other cities, we will need to be provided detailed GIS datasets about their existing underground water systems, and the agreement, of course, to share the data and provide access to their sewage and stormwater systems. In this case, we can prototype the same things in other environments, not only in Tallinn as well. So this was my introduction in a nutshell. This topic has been developed in collaboration with Marek Ruusma, who is professor of biorobotics in our university. And if you have any questions, I'm ready to answer them. Thank you.
Any quick questions online or here? Here, none. I don't see hands online. So yeah, as it is, please contact Ivar and discuss the details how you can become the partner. Okay, thank you. Then we are going to the kind of larger domain of natural and human disasters and how we can manage and prevent and so forth. So we have 7 different ideas here. We will start with the civil protection toolkit. I guess it's Wolfgang, yeah? So I will see if I now manage nicely to share it also online. And let's see. Okay, just wait a minute. So we take here that it's shared. Here, share. Okay, go ahead.
Yeah, thanks a lot, Külle. Yeah, as already in the last 2 presentations, we also deal with something you could say is placed in the wider area of emergency management. Bit in
okay.
Yeah, difference to the last 2 presentations. We do deal with different types of emergencies, so both natural emergency like Flooding was already mentioned, but maybe also storms and or fire, all kind of natural emergency. But we also deal with human emergency. So if you look at the current geopolitical situation, we also deal with what could happen, for example, in a kind of war-related situation or in another kind of human-made emergency situation. And this is a bit different than we have heard so far regarding the cities. So this is really an idea which was which was addressed by some city partners already. So both Saaremaa municipality and Jelgava in Latvia, they have actively approached us with this idea, and they have, we already had a couple of talks with them, and we have agreed on, at least a very first outline what could be the project idea. And the project idea is as follows. So at the moment, when we think about emergency management, we have a lot of rather centralized, fixed systems of shelters, fixed system of infrastructure. So they are placed in a certain location. You cannot simply move them around. And also this was the idea that was addressed by at least these two cities, and there may be also other ones we may know from earlier rounds of this competition. So their idea was we need something more mobile. We need a mobile solution. We want to move around, for example, shelters. We want to move around these emergency infrastructure to be more flexible and also more independent, for example, from the centralized public electricity grid. We need decentralized electricity supply solution. We need decentralized logistics solution. So kind of the basic idea, really make it a mobile solution. And the idea with the mobile solution is also that, of course, also here a lot of data collection, a lot of service development is included, but with this mobile solution, you really would also have a kind of a physical product. So you need these containers, or whatever it will be at the end, you need these mobile infrastructure to be really also produced and constructed and maintained by also private investors. And that was also something that the cities have pointed to, that we are already cooperating with some private companies who are thinking at the moment that they could maybe provide such services also more tailored to the city needs. And our team, it's also like we have heard before, it's very interdisciplinary. I'm from operations management, management science, but we also have people from logistics, discussing with people from sensoric, but also people from law, because there's also a lot of public regulation involved. And this is so our very basic working model that we say in the ground. We have the solution which is basically in use, or which is available today, that we said we have a centralized emergency management solution. We have fixed shelters, we have fixed infrastructure. We are, for example, dependent on the public grid. And then there are different levels of scaling up to a more mobile solution. So it could be, in a first step, it could be more basic services like food, first aid, water, and so on, survival needs. But then when we go on in a more elaborated level, it could also be more kind of complicated medical care, telecommunication, more engagement of more complex sensoring solutions. So I think that was it also. Maybe very brief. So there are organizational components. So also what was mentioned here already, it's about data collection. It's about forecast scenarios, what data we have already available in the cities. And there's quite a bit what we have learned from the cities. It's about guidelines, but also, of course, there's this technical core. So there is this solution of mobile shelters and the surrounding infrastructure to make this mobile solution, mobile emergency management, workable. That was it already. Thank you. If there are any questions. And of course, there's the willing. We have already in the past also cooperated with some of the presenters also from today. And of course, after today, we will also try to get into a Taltech internal discussion if there are maybe some solutions that still could better be combined.
Any questions? Online here? No? Then thank you, and we continue with ideas in the same domain, so you can also see if there is something you can cooperate with.
You.
So next, we have Smart City IoT for Safe Cities from Anna, but I'm not sure you are present because you said you understood that the companies get money, but they don't. Anna, you here?
I was a bit unsure about that part since we are tech providers.
Yeah, and
Sorry?
maybe some people would be interested anyway from what you already have. Go ahead.
Yeah, so I can present and then we'll see what happens. Okay, perfect. So can you see my screen?
Yes, put it in the presenters mode and then it's all okay.
Okay. There you go. So yeah, we are Mosaic Factor. I'm CMO and product manager. We're an AI and big data company in Barcelona, based in Barcelona. And we both run innovation projects, our R&D projects based on big Horizon initiatives and private projects for development. So the challenge we were thinking to address is the lack of real-time knowledge when roads remain totally collapse during floods. If they are open or they are closed, if they are practicable or not, which undermines the response to the emergency, the continuation of services, and overall the safety for citizens. Current solutions are siloed. This means they are separated, they don't talk to each other. So there are forecasts on the state of the flooding and the areas. There are traffic monitoring, there are static flood maps, but nothing of this is connected. So there's no actionable guideline for that. And so there has been huge impacts because of this lack of real-time information and this lack of connection in different locations. So what we are proposing is to build a digital twin for an urban digital twin. So it's mainly thought of for smart cities to provide safer cities. This, of course, takes into account cities that are censored. So for sure, we are a software company. We wouldn't be the ones, establishing the hardware. But we would integrate sensor networks, hydrodynamic and sewer models, traffic and asset layers of cities, and create a decision engine, which is our core. And of course, our expertise on the digital twin development. With respect to existing tools, what we are proposing is coupling high-resolution hydrodynamics and the traffic and accessibility model of cities, plus this decision engine. So this would allow for crowdsourced reporting that generates and addresses sensor gaps and improves the calibration for models, for existing models. So we would get outputs such as real-time flood forecasts and nowcasts, so what is now and what will be, road accessibility scores, service and continuity planners, and citizen interface for alerts. So driving a solution that addresses different user levels. So this is how we will ensure this happens. So with the data collection model, the architecture for the digital twin, then the integration of the model to do some specific closed tests to then pass to the trial prep and training and do live trials. At the moment, we have what we would have the R&D team assembled. So we have machine learning engineers, software architects, data scientists in our teams, and project managers specialized in mobility for innovation projects. But we don't have anyone from hydrodynamics experts, which would be a great role to integrate for this project, and emergency services and utilities for the sensor feeds, which would be really, really keen. We have been in talks with Bağcılar municipality in Turkey, but of course we would be keen to have any other cities for piloting, which would of course increase the expected outcomes. So I think that's all.
Yeah, thank you.
Thank you.
Yeah, thank you. Yeah, so she's online. So anyone wanting to ask questions, you can also approach via online. And we have also other mechanisms for supporting such kind of initiatives. So yeah, we can be in contact anyway for the follow-ups.
Thank you very much.
The solution would come from Hubcast, from Mohammed. Are you online? About real-time disaster resilience digital twinning.
Hello everyone, I'm here.
Good. Yeah, feel free to share the slides.
Sure. Can you see the screen?
Coming. Now we see. Yeah, go ahead. You can put in the presentation mode as well.
Sure. Hello everyone. Hello everyone, I am Mohammed, co-founder of Hubcast. Consider this harsh situation. It's now 3 a.m. and magnitude 7 earthquake struck in Istanbul. Around 740,000 people must evacuate immediately. Which roads are blocked? Where should ambulance go? And who need most urgently help? So emergency responder make decision based on outdated map and fragmented data. And current system are 20 or between 20 and to 40 minutes too late. This is the challenge for this scenario: fragmented data across department, fire, police, and infrastructure, slow reactive response, no real-time visibility, no predictive simulation, and delay and generic alert. So what we focus, we are addressing operational fragmentation and the lack of real-time hazard intelligence by our solution, which work as a hub between different stakeholders in this system. So our solution provide 3 different breakthroughs. We predict hazard impact, for example, measure earthquake damage, flood paths, fire propagation. We can optimize route deployment by our AI in order to position emergency vehicle, rerouting the block road. Moreover, and at the last but not least, multi-channel emergency alert in order to be confident about our notification to fill waters. So our solution is fully compatible with existing infrastructure. We can use all sensors, CCTV and GIS and other sensors. Moreover, we don't need hardware. We are software solution. Our solution is compatible with IMM Istanbul platform and Estonian geospatial standard. Moreover, we are in negotiation with globally recognized smart city technology provider. And why Hubcast? We are 10 plus years in IoT and building management system. We have proven a prototype and a smart city alignment project. We have privacy first design, and we provide European scalability in order to expand to other cities. And what makes us different from others? We connect prediction plus operation plus citizen alert in one unified platform. And this is our invitation partnership. So we are looking for partner in Estonia and other European cities. Moreover, we consider Bağcılar as our potential strategic partner. Moreover, we are looking for researcher in the related area, IoT, cyber physical system, and so on, in Taltech. I will be in Estonia in January. If you are interested, we can meet up in person. And if you have any question, this is my email.
Very nice. So I hope some of the Taltech researchers and cities will meet you in January and you can discuss it in detail. Any quick questions? Not at the moment. So we will see, we will have some more to go in the same domain. The next is from Bologna University. Is there someone on board from the Bologna University about the flood resilience? Yes, I already see that some slides coming. We don't still hear you, but.
Okay, can you see me and hear me?
Yes, put on the presenter mode as well.
Yes. Okay, sorry. It's on the other. Let me see. Can you see the presentation, right?
Yeah, but we see also the notes.
Oh, okay, sorry. It should be like this. Can you see now?
The same.
The same. Okay. I'm not really.
Not in full screen.
Does someone has the microphone on?
Okay. Can you see now?
We don't see any difference.
Now you should see the presentation, right?
Now it's yeah.
Yes.
Okay. Sorry for this. Okay. Thanks. And good afternoon. I'm Alessio Domenighetti from the University of Bologna, and I have the pleasure to present the solution we developed together with a larger group of colleagues from different research institutions and also private companies, as you will see here on the first slide. Unfortunately, we are all aware that our cities are really not fully prepared to face the consequences of flood risk whenever it comes from intense rainfall or riverine inundation or a storm surge. This is because floods, of course, cause many different problems for different assets, not only people, of course, but also business activities and also infrastructures. This means that it's quite challenging to face all these aspects, and managing such risk requires the need to face not only the hazard and risk assessment, but also the forecast, the monitoring of such events, and also the communication phase, together with the infrastructure development, design, and also the urban planning. So the ideal solution should be something that is scalable in space and time, but also multi-layers and dynamic. So building upon this awareness and also building upon such technology solutions that are already in place, our idea is to further develop provide some tools provided, for example, by Safer Places. It's a private company providing cloud-based solution for the assessment and mitigation of multi-hazards like fluvial, pluvial, and coastal risk. A different solution also at the city level. It's capable to combine satellite information together with digital twins and very detailed data. And their solution have been already implemented in several municipalities and also civil protection agency, being suitable not only for emergency management, but also for planning. And together with this company, we have a second one, is Green Metrics, part of the partnership, is a leading company providing continuous monitoring system of environmental variables, such as water depth, for example, but not only. They can really provide a continuous monitoring of the critical infrastructures, and based on that, we have alert system and the possibility to really reduce the reaction time during critical events, for example. And also in these cases, their solution have been already implemented in several cities around the world. So the innovative part will be, for sure, first of all, the integration of these two companies and their valuable solution and technological tools. But also we would like to further develop other capacities. So the modeling part in terms of hazard assessment and risk assessment, integrating the system with additional layers that also is based on the availability of additional additional digital twins, for example, for several infrastructures, but also road and similars. And of course, also to improve the citizen awareness, so the capacity to respond, to be, let's say, effective during the management phase also. So the developments actually will be identified based on the collaboration with the municipalities that would like to collaborate with us. So based on the data available, their peculiarities, the needs of each cities, the solution ideal will be flexible and scalable. And so I would suggest you to look at the solution already in place and get in contact with us in order to see how we can shape and tailor our solution and further develop the platform. Here are the list of all the colleagues involved and also again the links to the partners. Thanks.
Thank you. As we see, quite many companies are quite active in this field, and we have several researchers doing something. So I hope you find good combinations.
Thank you.
And now I think Dirk, you will be the next one. I will share that. Just a second. I will find the slide and yeah. Number 20. Yeah.
Can I interrupt? Yeah.
Do you have a news? I hope this is yeah. Good. I will just verify. Full screen. Yes, everybody is seeing you. Good. Go ahead. Do you want the new slide? Okay.
Yes. Hello, everybody. This here. Integrated Resilience Intelligence Platform. So the addressed problem is about the safety in case of natural human disasters. It's a conglomerate of challenges proposed from 10 cities. Basically, those 8 cities, have problems with flood, basically. And 2 cities have a problem with earthquake, particularly in Istanbul and again, Istanbul district. So the addressed problem is data and flood modeling, traffic simulation, IoT device orchestration, and public warning and cell broadcasting. So data flood modeling gets input from numerical weather prediction, rain, snow, wind, sea level, and storm usage forecasts, snow, again, soil moisture data. And it's about simulating the full water cycle from rainfall to water and rivers, lakes, and groundwater. Traffic simulation, modeling urban networks, including streets, car, bikes, pedestrians, and so forth. Key ports, bridges, ferries, real-time traffic surveillance and simulation. IoT device orchestration, IoT sensors, water level gauges, tidal booths, rain gauges, roadside units, and so on, weather stations, cameras, drone cameras, LiDAR, public warning and cell broadcasting, automated and semi-automated public warning, and feedback loop from social media and Twitter optionally. For earthquake support, there's no genuine support in the problem that we address, but can be discussed optionally. And traffic simulation, IoT device orchestration, public warning, all these things are of course also utilizable in earthquake scenarios. So the solution. So that is a problem, right? And not the solution. That is the solution. So we built on open source technologies, best of breed that are available. So at the center, we have the fireware for the IoT device orchestration. It's a huge EU project that has many case studies, lots of funding inside. And then we built for the traffic simulation on Sumo. It's the best of breed application available. No need to build these things again from scratch. So it's from the German Aerospace Agency. Then we have ListFluid. This is also a EU project for the data and flood modeling. And as I said, we combine those best of breed components into an open architecture that is sustainable and also adaptive and flexible in the future. So, and then we have the free resources to do what is needed. Going beyond the state of the art with some AI components, because we want to also publish them in high-level journals in the end. So that comes from Tritec and an innovative AI layer based on graph neural networks. So we do have public warning cell broadcasting on the, for example, in Estonia, we do have Ole Valmes and the pocket siren, whereas Ole Valmes is a more official one, and it's a huge project and lots of resources are going inside there in 2027. So yeah, so here we have all the IoT devices. Also, we care for the integration of existing systems and existing data systems because the overall architecture is open, flexible, and adaptive. So here we can see sources, least food, what all can be done, what can be done with Sumo, just the screenshots. And yeah, we do have an innovative AI layer. We want to go beyond what is available already in this food, Sumo and Fireware. So we want to model with sparsely temporal graph neural networks. Inputs are then from this food, IoT sensors and Sumo. And yeah, we predict, for example, with uncertainty probabilities that each road remains passable, each feeder remains powered, and each cell tower stays on air. We recommend control actions, and the point is that we need to go with a certain percentage of the work we need to go beyond what is already available, state of the art. So piloting, all components needed for the solution are open source. No additional are required. Both Lisfood and Fire are a solution of very large, well-funded EU projects. Therefore, Lisfood and Fire are extremely stable, well-tested in the field and well-maintained. Sumo is best of breed in its domain, and given the experience of Tritec and our partners, we will achieve a technology readiness level of TRM7, system prototype demonstration in operational environment. So very high technology readiness level in our project. Advantage summary: all components are open source, best of breed. German Aerospace Center, Sumo, with very large funded projects. So therefore, also everything we do is GDPR compliant. We do have a component architecture, future-proof, extendable, adaptive, open adaptive architecture, allowing for the smart integration of existing city solutions. It's a turnkey tailored solution. There's no vendor lock-in and no proprietary product lock-in with us. So, and we do go beyond the state of the art with AI innovation. We do have an innovative AI layer, sparsely temporal graph neural networks, usually done with Playbook nowadays. It's also available in Keras, but PyTorch is currently the strongest one for the graph neural networks. So our team, I'm Dirk Draheim, Tritec National Professorship of Digital Society Technology. My team at Tritec is around 10 researchers now, and I have reliable access to 300 plus leading high-end AI tech experts and developers worldwide. I have just selected 3 publications. We have lots of publications, but as you can see, we have done in projects. These are, of course, outcomes of projects that we have funded projects. Rising role of big data analytics in disaster management. Yeah, resilient towards disaster resilient cities, all top publications IEEE access. Twitter streaming data analytics for disaster alerts towards exploiting social software for business continuity management. And our partner, also currently very much involved in our projects, is Professor Arun Sangaya, UNTech Distinguished Professors. And he has a lab of 30 researchers at UNTech, and he has reliable access to like 1,000 leading high-end AI tech experts, developers worldwide. And he has also published a lot exactly in that area. So we do have the capability to perform together with our partners, and we go for the open solution and this high-end AI contributions.
The time is up, but yeah, very good, competent team. So in case you want to cooperate or exactly pilot this fund, yeah, please contact them and yeah, see what can be done. Okay, now we go for the next one. I guess Luisa is on the other side of the world, but wants to share the slides. Luisa, are you there? Yes, seem to be coming. We don't hear you yet. We see the slides, but we don't hear you.
Now you can hear me.
Yes, we can. Okay, go ahead.
Now you can hear me and see me in presentation mode, right?
Yes.
Perfect. So good morning or good afternoon. I'm Luisa, as Külle said. I'm a researcher of the Finnish Center for Smart Cities, and I will be presenting the two last solution ideas of the challenge safety in case of natural or human disasters. So, well, the challenge, it was already described here, but here I have some pictures of Porto Alegre, who submitted one of the challenges. And this huge flood that, of course, last year proved that there is a lack of preparedness to deal with disasters. Just to illustrate where is Porto Alegre, so it's in the south of Brazil, so the other side of the road where I am right now, and it's raining today also. So yeah, maybe it's a sign. Just some numbers. So there is in Europe, floods are the most common and costly natural disasters, and an important thing here is that unfortunately, extreme rainfalls and precipitation events are on rise. And there is floods in areas where before it was not that common. We identified a gap of communication and engagement, a lack of real time, a lack of information flow, like in the two ways, and unified situation awareness. And this results to delayed decisions, increased risk, and damage. Here I also bring some pictures of Parno and sorry, it's a little delayed. Okay, yeah, and the case of Valencia as well. So, well, we all know that there are like a lot of issues related to flood. Before going to the solution, the two solutions in a little bit more detail, I would like to show this disaster management cycle. Why? It's because when you're dealing with floods or natural hazards, you can act in different stages. And the solutions I'm going to present, they are a little bit, they are more focused on the response and recovery phase. So the first one is the Natural Hazards Resilience Toolkit. The idea is to develop the collaborative smart community toolkit that will empower communities and improve disaster response and recovery. We built the idea on the collective crisis intelligence that is able to merge top-down information with bottom-up crowdsourced data. We plan to use AI to analyze this data, including real-time hazards reports from social media and other to-be-defined channels, and this will be defined with the cities. And this data will be verified, unified, and displayed in a real-time map showing risk areas. The solution also includes a social strategy to engage people and raise awareness about the risks related to natural disasters. In terms of innovation, is this enhance of the two-way information flow, because this was identified as a big issue during emergencies. And the current solutions are usually one-way alerts, like either like official alerts or unified information sources. So it's hard to find the necessary information in one place. And we also have this strong non-technical focus. In terms of the pilot components, the real-time monitoring and the awareness and actions, and also the community collaboration tools. Here I just bring some examples. So this idea came from one solution that is in place, is widely in place in Asia. They have more than 350 million users, and then it's the idea is that you don't need an additional app, like the citizens, they can report something using the channels that they are used to use, and this information is gathered there and put in a real-time map. Okay, this I'm not gonna show, but it's just like some reports. And then the other solution, because I submit both of them, but there is high potential of combining either my two solutions and also the others that have been presented today. So the other one, it's RESCUS, so it's community mapping. And this idea is to create a platform that leverages open data and geospatial technology to map and optimize the distribution of emergency resources. The main core functionality is that it uses demographic, meteorological, and spatial data to create this interactive map, which will categorize the areas by urgency and will track available resources, list shelters details, and calculates the safest transit routes. In terms of innovation of this specific idea is a transparency, an overview of ads and its destination, fostering trust and accountability. And citizen empowerment as well. So we would like to include features like tracking of donation and create things, for example, awarding badges to gamify this engagement, to foster citizen engagement. So the components would be this map and the 3 sessions that we would include in the app if the final decision is to develop an app. So the maps, the shelters, and the profile. So I combined the expected impact of the 2 ideas. So if we would be able to integrate them, then we will have like smarter communities, so they will be able to participate in real time, the awareness, so they will be able to understand and share data, efficient resource allocation, so this access to real-time data will foster a better decision making, the long-term planning and sustainability, so this data gathered during disasters can serve and can bring valuable insights for the long-term urban planning, and the aspect of volunteering and logistic management. So this will streamline volunteer coordination and resource distribution during emergencies. This was, as described by Porto Alegre challenge, this was a huge challenge. It was very difficult to know who were in need of what last year during the flood. Okay, so just coming back to this disaster management cycle, the first idea, the Natural Hazards Toolkit, this will ensure an immediate response, as we will have this real-time and two-way communication and situation awareness. And the RESCUS, it's mostly important for the recovery because it will take the data and translate into optimized logistics and resource allocation. In terms of the team and the pilot city and partners, so the team right now I am one the team. Then Jamara Luciano from Porto Alegre, a researcher from PUC. Then the technical team, we have 3 persons from Tautec, so Avelin, Maptab, and Yannick. And then we plan to include someone of the crisis management, a crisis management expert from the NURCS department, Tautec as well. And we have the business Luna Palladino from University Federal of Rio de Janeiro. Pilot cities, Porto Alegre, already on board. I mean, like strongly interested in being a pilot city. And then we identify Pärnu as a potential pilot city. And then we are open for others. And then we would like to know if there is similar projects or solutions. Well, I'm the last one presenting for this block, so I can already see some potential. And that's it. So thank you very much for your attention, and please let me know if you have any questions and if you want to collaborate either with one of the other one or the combined solution. Please contact me. Thank you.
Thank you. And definitely 17. So I think if we want to go independently or join forces in something, that you're very welcome to present certain ideas, but you can also come with the combined one. But of course, then the cities, you also need to think which ones you believe mostly in and want to join. Okay, but now we go to traffic data insight for the city. And there we have 2 ideas. The first one comes from Davis from Latvia. Do we have you online?
Yes, can you hear me well?
Yes, we can. Slides are
Perfect.
coming. Yeah, we see it all nice. Go ahead.
Perfect. Right. Hi, everyone. I'm Davis. I'm from Riga, from Latvian mobile telephone, and focusing on cities and the traffic and mobility aspect more specifically. What we see the challenges and have developed our solution for is automating some of these aspects of gathering data, providing real-time and quality data to cities. But some of the aspects that we have encountered that are crucial issues for cities is the scalability of such solutions, because many IoT solutions, they serve a single purpose. You have to get a lot of devices to actually get reliable data across city. And it's still challenging, therefore, to identify these safety hotspots across the city. And how we propose to do it and have dealt with that so far is using the existing city's surveillance camera infrastructure. So essentially, we connect to the video management system and don't require any additional hardware to be installed. And with that, with computer vision algorithms, we then get both the statistical data of different objects going through the city, traffic, cars, micromobility, pedestrians, and so forth. And we can also do this in different kinds of weather conditions, as it is very challenging in Latvia and Austria as well. And the second part of improving the safety is also the enforcement part. So not only passively monitoring and getting the statistical data, but also identifying and registering red light violations, speeding, bus lane infringements, and doing all of this while still complying within GDPR norms. And this just shows you how, for example, nationwide, across nation in Latvia, there were 740 overall recorded red light traffic violations last year. But with the solution at a single intersection in a span of 6 months, it was 4 times that. So I usually like to make a bet to the city that they actually don't know how bad the situation in some places might actually be. And we work and have experience in different innovation areas, and we have connections with academia, with other companies. So we're very flexible in adjusting the solution to the city's needs. And yeah, from Taltech, we also see potential to work with researchers in developing new algorithms for the analytics part and urban planning expertise to kind of connect this more with even more insight for the cities. And we're currently open to talking with any cities interested, as we are expanding our cities network as well. So yeah, that's in short from me. Thank you, and I'll be happy to chat with anyone interested.
Yeah, great, thanks. And now we also will have the second proposal to the same thing from Dick again, I think. So we will see. Do you match together, or you're really done? 24. Okay. Fine. Let me share as well, then they will also see it. This one. Yeah. Okay.
Excellent. Safe Mobility Intelligence Platform. Yes, so Cesis municipality in Latvia has accumulated large data sets from traffic counts and public transport, and they would like to utilize those in analytics, traffic data insights. So it's about analytics and decision. Yeah, the problem would be to have multimodal mobility dashboards for visualizing car traffic, public transport, cycling flows, pedestrian volumes through heat maps, direction-based flows, occupancy graphs, temporal patterns. identification of peak stress points, underserved routes, seasonal and event-driven anomalies. So to have a safety and conflict risk index, a real-time risk index per road segment or intersection, probabilistic hotspots, multimodal conflict potential, for example, cars versus cyclists, pedestrian versus vehicles, weather sensitivities, event sensitivities, time of day risk spikes, for example, school hours. Yes, to have a public transport demand and optimization analytics, forecasting demand-driven frequency adjustments, route extensions or short-term loops, optimal position of interchange nodes. Then means for simulation and policy testing, testing policies and infrastructure safety before implementation, intersection redesign or signal retiming, new site lane configurations, bus route restructuring, bus frequency changes, integration with micromobility. Then data integration and event-driven pipeline to have a modular integration of new data sources, continuous availability of fresh data for dashboards and simulations, and scalable real-time ingestion. So the solution would be based on the leading streamlining solution from Apache Foundation, Kafka. And so with those, we integrate the existing data sources in the city, which is standard to do it with Kafka. We have very much experience with Kafka, for example, in the implementation of the digital euro. We built the prototype for the European Central Bank, and we had a Kafka pipeline underneath of that also. And yeah, so on the solution side, we do have this Sumo best of breed open source product from the German Aerospace Agency for simulating and policy testing. And for analytics and decision, we go for the Apache Superset, which is a absolute superb analytical open source platform from the Apache Foundation. And to go beyond the state of the art, we would add layers of AI innovations, an AI safety model, and an AI counterfactual engine. So these are screenshots from Superset and this from Sumo. So innovative AI layer beyond what Apache Superset and Sumo offer individually anyhow as state of the art. The solution adds certain AI innovations. So we would go for an AI-enhanced spatial temporal safety model based on graph neural networks, again, PyTorch. So real-time risk index, scientifically defendable basis for prioritizing low-cost safety interventions and planning longer infrastructure projects. And we would integrate an AI counterfactual engine for allowing to test not only engineering, but also operational concepts like dynamic timetabling, event day traffic management, adaptive cycling corridors, and resilience planning. So the piloting, all commands needed for the solution are open source, no additional are required. And given the experience of our Taltech and its partners and previous projects and also companies in our network, we will achieve a technology readiness level of 7, which is very high. System prototype demonstration in the operational environment, so it actually works then for the cities. Advantage summaries, all components are open source, best of breed. Sumo is from the German Aerospace Center. We use Kafka and Superset from the Apache Foundation, worldwide tested. It's a component architecture, future-proof, extendable, adaptive. We provide a turnkey tailored solution, no vendor login, no proprietary login, and we go for AI innovations. So the team is me, I repeat that. Maybe others speak very quickly. I'm the Graham Taltech National Professorship of Digital Society Technologies. And we have lots of projects experience. My current team has associated 10 researchers at Taltech. And we have reliable access to 300 plus leading high-end AI experts and developers worldwide. And yeah, we have genuinely worked on these topics, intersect and accident data sets, cluster-based associational mining with cross-city incident predictions. All works from Mahtab, my PhD student. She defended her PhD with me. And yeah, we have as a partner Rahul Kumar Sangaya from he's UNTech distinguished professor. He has a large lab of 30 associate researchers. And he also published in the area of traffic flow, short-term traffic prediction, and traffic classification systems, and so on.
Thank you.
We would be splendid to team up and design a solution for the cities.
Yes, great. Thank you. Thank you. So have a good discussion. And yeah, we still have quite some to go in this slot, so try to keep your 3 minutes, please. And now we go to safe and attractive cycling infrastructure, and we have Myra Leia. So I hope you're online.
Yes, I'm online.
Yes.
I will share my slides.
Fine. We see just the presenter mode. Yes,
Okay.
good.
Good. Okay. Yeah, I'm a senior researcher at the Department of Computer Systems, and our goal is to improve the urban cycling infrastructure to promote safer and efficient urban mobility solutions. And there are different challenges we are facing. Creating the safer and user-friendly cycling network. Infrastructure is actually fragmented usually. Inconsistent standards, unsafe functions, and also insufficient links to the public transport. And also there are lack of spaces for secure bicycle storage facilities. And usually the Cycler app is the tool, international standard. It is used for the infrastructure analysis. It's deployed in 120 countries. And it's using 50 plus attributes and combining all together this. And below you can see also that it gives some scores how safe is the infrastructure. And there are many different potential partners who could use it. For example, the delivery partners, insurance companies, transport planners, and policymakers. But the problem is that many of these attributes are analyzed manually. And our idea is to collect the data with the help of a Lane Patrol mobile app, which is provided by the Factual Consulting. It's one of our partners. And also analyze also the infrastructure, leveraging the Cycler app standard. And also automate different attributes analysis with the help of computer vision technologies. Using the object detection, image classification, semantic segmentation, and also include all external sensors for the analysis. And the outcome of this project would be the toolbox that automatically helps to analyze this infrastructure and extend also the current functionality with the help of additional sensors. In case we are able to fully automate it, we can speed up roughly up to 10 times compared to the current manual approach. We can reduce the human errors, and the current manual approach doesn't prevents actually to analyze networks which are more than 200 kilometers long, and also to include additional information, for example, the traffic flow, air quality, and other options. Currently, we have one partner, which is the Factual Consulting from Barcelona. they are actually doing daily basis similar things, but they do it fully manual. And they also have city connections with different cities. And also we have pre-agreement with Barcelona, Lviv, and the Tartu. But of course, these agreements need to be confirmed yet. And we are looking for 1 to 3 more cities for piloting. And I'm putting together now the development team. And we also need the business development expertise in this. And yeah, that's all. Thank you.
Thanks a lot. So I hope some of the researchers will contact you, and also some cities would be interested to join or confirm. Okay, so now we go to urban freight loading zones, and we have 3 proposals here. I guess Ruth is you are okay. So I will put your slides on. Yeah. So I will also share. Yeah, go ahead.
Hello, my name is Ruth Laigu. I'm from Tallinn Technical University of Applied Sciences. And we chose the smart loading zones for freight because in July we had a new traffic act that we can't anymore. We're not allowed to park on the pedestrian way. And currently it's a big issue because, for example, in Tallinn, there isn't like those kind of places where you can do your unload your freight. Sorry, my English is so good. I'm not talking every day, so excuse me. So here are some examples. These are our challenges, and we need to find the solutions for them. And our solution is a little bit like combined, and it is fast to implement and internationally validated with different research articles. And here I come. This is solution 1. It's combined. As I said, it's the first one is like this structured loading phase with definite time windows. So this we can get conflict-free delivery flows and reduce double parking. Then smart loading zones with digital booking through app, or, for example, integrate with the fleet planning tools. Drivers can reserve a loading space in advance. See a real-time availability, comply with the permitted dwell time, and avoid unnecessary circling and wasting fuel, less fuel. And for that as well, we can city can gain data on freight activity, which is essential for planning and curbside policy in the future. And the third one is curb extensions, loading buckets in constrained streets where the sidewalks are narrow. We can create small curb extensions, compact, safe loading buckets. And we need people and partners. We are reaching out to Tallinn because in Estonia, Tallinn is big issue with freight parking, and we are waiting for other cities from Europe as well, and companies who are experienced in creating digital booking software solutions for vehicles, physical marking of parking areas, hardware installation and maintenance companies, and daily operations of parking control services. So there is my contact if you have any questions. I can answer them.
Yeah, Maris, go ahead.
I just have a comment or a question that isn't one of the challenges the fact that the people wanting to load the goods, they want to load them in front of their specific, let's say, shop or service provider. So if you provide, then you would have to provide like specific allocated slots everywhere because they only want to.
Yes, we have to do, for example, if you think this pilot project, we want to have like, for example, one street and find the spaces where it's most optimal to move, because it isn't possible that you can stop in every meter.
I guess the comment was for the fact that they could still even currently park their car at places like parking spaces or whatever, but they don't want to do it because they want to park in front of so we are kind of trying to, your solution is trying to tackle a challenge which is kind of, in a way, there are places to park, but they want them to be in front of their, you know what I mean?
Not really, because in, for example, if you take Tallinn, Pärnu maantee, I don't know whether you know it.
Yes.
There isn't any place to, like, special spot for the freight delivery guys to park.
Probably, yeah, but you can find a place in a parking space.
No place in the center of the city.
Okay, but yeah, you can definitely discuss because there's Maris, I think, from Tallinn, the city, who proposed it. So the combination, I think we have two more for the same issue. So maybe there is a combination in reality that comes. So Victoria, do we have you online?
Yes, I'm online.
Okay, go ahead. So let's see how, does it add up to this one or how? Yeah, go ahead. Share the slides.
Sure. Do you see my screen, right?
Yes, just, yeah, I think it comes now.
Perfect.
Yeah, good.
Well,
go ahead.
Yeah, okay. Hi, my name is Victoria Pilenska, and I'm an architect and urban planner. And I work as a research fellow at Finnish Center for Smart Cities. And today I'll show you how we can unlock hidden parking capacity and make streets safer in dense city centers. And this particular pitch is aimed at city representatives, but also for our other teams who might want to join forces in technology, analytics, and logistics. So the challenge. In our busiest districts, everyone is fighting for the same curb, right? Vehicles, residents, office workers, and shoppers. And the result is familiar: cruising for parking, illegal stops, blocked sidewalks, and safety risks for pedestrians and cyclists. So the original Smart City Challenge focused on freight loading zones. I fully support that, but I'd like to extend the scope to all curbed and nearby parking in the districts, because freight residents and visitors all are competing for the same space. So the solution. The idea is to treat all parking and loading assets as one coordinated system, as not in separate silos. So we would need to install real-time occupancy sensors, or we can do it with the cameras, on curbside spaces, loading bays, and selected private parking in housing, office, and commercial buildings. All the data will flow into a unified platform integrated with the city existing parking or mobility app. So in some cities, we have already such mobility apps. And drivers would see where legal spaces are available, get clear rules and pricing, and they can navigate and pay seamlessly. So for freight, we would introduce smart time windowed loading zones, and logistics operators can get predictable legal access instead of double parking or blocking sidewalks. And this directly would support the key message. We would reduce the congestion and safety risks by using existing space much more intelligently. So what's the innovation then, and where others can plug in? So today, most cities provide separate tools. So let's say, so you can see it better. One system is for public parking guidance, another for loading bays, another for private building access. So they rarely talk to each other. Our innovation is to unify public curb, private housing, office retail parking, and private loading zones into one single data-driven system. A key feature would be a dynamic parking swap. For example, office parking can serve residents in the evening, residential parking can serve office workers in the day, and commercial parking can support commuters on weekdays. So for other startups, there is a clear plug-in point. So advanced analytics, logistic optimization, enforcement tools, user-facing apps, and integrations with existing platforms. So, oops, somehow my presentation stopped and I cannot continue. What happened? What happened? Yeah. So what's the pilot impact and our ask? So concretely, we are looking for 1 or 2 pilot districts with a mix of housing, offices, and retail. And the cities would provide the test area, integration with the parking app, and policy support. And I would bring the urban planning and concept leadership. And I'm seeking also for Taltech researchers and startup partners in IoT, data analytics, mobility modeling, and service design to build and test the technology. So the impact is clear: less cruising, fewer illegal stops, safer streets, and better use of existing parking spots instead of building more parking spots. So to close, let me repeat some of the key points. So curb and parking chaos is real, shared pain. We would offer one coordinated data-driven system with dynamic parking swap. And we would invite cities and startups to pilot and scale this together. So thank you, and I'll be happy to talk about piloting after the session. So I already see that we have some clear overlaps with some other pictures today. And also I wanted to say that, by the way, I have also an MBA, so I could be also your commercialization partner, not only urban planning and architecture expertise. Thanks a lot.
Thank you, Victoria. The third one comes from Davis from Latvia again, so that's more technical solution, I guess. So you can see how you can combine. So
I hope that it could be a good match, since you are exactly looking for an architect and planner.
Yeah, for sure. And in fact, I think the previous 2 presentations were also very relevant to us, especially about, for example, the having these dedicated zones and times for loading, and we can ensure this aspect of actually enforcing and seeing whether that system is working at specific times. Although this is a logistics center, the concept kind of translates to this freight zone monitoring, and we can go in 2 directions. So one is monitor either these specific spots or curbs in general and see where the biggest occupancy of trucks is, or where's the biggest demand for them to stop, and then kind of base the decision of building out specific spots for unloading based on that. Or the other part is we can already start enforcing that. So for example, say we have 15 minutes or 30 minutes for the truck to stop, then we can automatically, again, using the city's camera infrastructure, see, okay, this truck entered at this specific time, and then in real time see whether they are actually using that time and then finishing in time before leaving. Or at the same time, for example, a private car has stopped in this spot, and we can make an alert and then get them out of there, so that there isn't this bottleneck that cargo trucks cannot use that spot where it's relevant. So I think this covers kind of the other part of what what the previous presentators already mentioned of what is crucial. And yeah, once again, we see that there is potential for researchers to be involved in this urban planning phase and analytics phase, where we could use then this data that we have gathered, maybe adjusting or making dynamic times for the trucks to unload, because sometimes maybe the trucks take 10 minutes to unload, maybe sometimes it's more, depending on the load, depending on the shop, and then we could explore how this data can then be used. And for piloting, we're also now open to different cities, and probably the issues might differ from place to place, as we already mentioned. Maybe the most city center, maybe it's a bit outside of that, but we're eager to seeing how we can adapt this to those specific needs. So yeah, once again, thank you, and I think I'll be happy also to connect with the previous two presenters to discuss how we could potentially collaborate.
Thank you. Okay, have good discussions. And we have a little bit less than 20 minutes and 5 ideas, so we should be very quick. But this is women's safety in public space, so safety for all in reality. So do we have Safe City for All? Someone, the guys who presented to online? I'm not sure I can pronounce your names, but do we have the presentation Safe for All? If not, we will go for the Vyacheslav or Juho. Women's, yeah. Okay, so right here. You're there. Okay, go ahead then. Sorry. Yeah, we see your slides, so you can stop. We don't hear you at the moment. Sorry, it's silence. We don't hear you. We heard, but we don't hear you anymore. Are you able to unmute yourself? Although you don't, you seem to be unmuted, but we don't hear you. Okay, maybe you deal with your, and we still take this next one first, and I hope you get your things working there. So let's still go with Vyacheslav then, yeah? So, okay. I will share. Yeah, go ahead.
Hello, my name is Vyacheslav Kekshin. I'm from Caltech Virmo College from Kohla area, and we offer one project for solution that is Smart City Challenges Women Safe Mobility App.
I guess this one. You should go from here.
Okay, here. And our project included great solution, a lot of benefits and innovations. And for example, there is solution mobile app to enhance women safety in cities. Real-time data, it is included AI-based risk prediction, dynamic safety maps, safe route suggestions, alerts and notifications, quick access to help. And if you talk about benefits, here is easy integration with existing city systems, high social impact, safety, mobility, trust, and predictive detection of dangerous situation. And of course, innovation. Here is AI-driven risk prediction, real-time, continuously update safety maps, smart routing with minimal risk, data analytics for urban planning and safety decisions, user co-creation involve women in future development. And an example I can say, by myself that if you have this mobile app, it will be like predictive analysis knowledge with different type of data, external data from, for example, police, from lighting distributor, city departments about streets. And for example, also if in the night time exists some nightclub, mini bars, we know that from this place can go a lot of people who has alcohol, and of course with alcohol every time a lot of accidents. And our algorithm is fixed all this data, make analysis by artificial intelligence, and we have a predictive knowledge that this in this situation this street is dangerous. And of course, every place in the city every time can be not danger and danger. And we have also analysis for it, and it's a very helpful. And we use not only this example, but I'm talking about these scenarios. We have another scenarios. And in our project, we have a good partner who is from Finland. It's Siam Applied Science University. It means that we can do together with Siam University this project, and we will make this project integration of this project in 2 different countries. It's also very nice because in different countries we have different maybe data, different departments, and we fix it that what differences exist, and it will be better to know for the future for if you use it to another countries, to another cities. And this last one slide, and we are looking for 2 cities where is can be Tallinn, Vantaa, Finland, and of course it can be in other cities who can come. Please welcome, and thank you very much for your attention. And my contacts is here, Digital Kitchen, and email also here. If you have some questions, please ask.
Yes, thank you. So there is already okay 2 questions. So go ahead.
My question is, so how you just push the woman to download and to use your app?
It's a good question. I'm thinking about it before starting on this presentation. Yes, we have, for example, accident. We have news that some bad accident is existing in some city, in some street. It's a very bad information, and also it's information for people that some dangerous situations exist in our city, and please be careful. And of course, this same maybe information can be also possible to know that exists some app, a mobile app, what can make your safety. And of course, this statistic of dangerous situation will be not so big if women will use this app, because it will be predictive knowledge. And it's, I think if this solution is exist in the future, here is a lot of social impact, and a lot of women will use it.
Okay, another question.
Yes, please.
Okay, but maybe it makes sense that we still listen to, and then we have an elevating break, and then we can, when we have heard all the kind of ideas to the same thing, and then.
Thank you so much.
But good that we have questions finally. Okay, but Etsi, are you ready now to share? Can we hear you? I understand that you have reconnected.
Are you hearing me?
Yes,
No.
we see your picture, so maybe, yeah, go ahead.
Maybe, yeah, just sharing the presentation. Maybe it will be better.
Yes, we see it. Go ahead.
Okay. Yes, I'm Ecem Polat and my colleague Nurcan Gülden. We are together presenting today SafeCity for All, a holistic safety model for inclusive European cities. Formal challenge is focused on women's safety, but in reality, we know that fear and vulnerability impact many groups, include women, youth, seniors, tourists also, and night shift workers and people with disabilities. Cities also suffer from fragmented data. There is no perception data almost, and weak prevention, equity gaps, and so municipality can't prevent and predict safety concerns. Now, SafeCity for All is built on a simple principle. If a city is safe for most vulnerable, it becomes safe for all. It is the first, maybe first, integrated European safety ecosystem to combine digital technology, urban design, and community engagement with a model that is ethical, privacy first, municipal led, scalable, and perception driven. On digital layer, we strained both people and municipality. For people, our mobile app offers three core supports: a silent one-touch emergency call and emergency chat, a safest route option informed by lighting and user feedbacks, real people feedbacks, I must say, and a walk together companion mode to share a journey or live location with trusted context. People also can rate how submit reports about issues, safety issues, also rate how safe they feel in different places. So everyday experience become visible to the city. In parallel, the municipality works with dedicated dashboards built on aggregated ethical data. These screens show where perceived safety is low and where avoidance patterns are emerging, enabling more effective interventions and more targeted investments. In practice, this means fewer blind spots, better prioritization, and stronger relationship between the city and its residents. At the urban space layer, we translate this intelligence into concrete spatial actions. Cities can identify high fear corridors, poor visibility, unsafe walking links, and underused parks, or focus investments on better lighting, clear sightlines, safer transit stops, and continuous routes. This change supports safer everyday mobility and better access for vulnerable groups while using existing public space more sustainability. At the social and cultural layer, under we Reclaim the City for All campaign, we mobilize community safety ambassadors from the groups most affected by insecurity. Through micro workshops and a Safe Hubs accreditation model grounded in community reported perceptions, we build trust, visibility, and shared culture of responsibility for public space. Together, these three layers connect insight, spatial action, and community engagement. They form a practical methodology that cities can pilot in one corridor and then scale up, making safety more inclusive, measurable, and human-centered. We invite all cities to join us, collaborate with us, and also we invite researchers from Taltech and Finest, mostly expertised in data, AI, data ethics, and ACI. Your insights combined with our framework can help create cities where dignity, accessibility, and belonging are part of the everyday life. Thank you.
Thank you. So we have two kind of app ideas. So let's see how maybe it's combinable. Of course, still the question stays how you attract people to download an app, but yeah, probably you are able to track that. But now we have
Actually, we are
Yes?
confident in that area. Nurcan and I, we are working about 5 years with Istanbul municipality, their mobile app. So over 7 million download we reach. Yeah, we can reach people. We believe that.
Okay, good. Great to hear that it's doable, but yeah, when we really see the benefits, so probably it's doable. So you will present, as I understand, yeah?
Yep.
Good. I will share this slide, and so the ones online can also see it. Yes, go ahead. You're pre-made.
Okay. Yeah, hello everybody. Nice to meet you. My name is Jan. Me and Svetlana from the side of Taltech are presenting you Hear Me, Acoustic Safety Network for Cities. Nowadays, we are facing a problem. Then 1 in 3 women, 1 in 5 children, and 1 in 6 older people are facing violence in public places, such as parks, routes, bus stations, and others. But the main problem is not that they are facing where, but how cities are acknowledged about it. As you can see, there is a timeline where is a moment of violence. We got the blue part, which is time which provided to help, and the red one when it is too late. Right now, cities are known about the harm after it happened, from emergency calls, hospital data, and media reports. Cities got infrastructure for such things, such as street lights, source cameras, SOS mobile apps, and acoustic sensors, which are mostly detecting gunshots and the glass break. We believe that we need solution in the blue zone, which help before it's too late. As a proposal, we think that Hear Me could solve this problem. How does it work? What are we looking for? Hear Me is the acoustic safety network, which are looking for female scream. In the sounds of the city, there are a lot of traffic, background noise, music, and others. But female scream at the distress sound has a unique peak, which could be recognized by form and the way it spreads and the way it melts. So how does the system work? First of all, we've got acoustic sensors, which could be placed along the place we want to scan, or it could be your phone. Sensor listens to the area, and if we detect the female scream, we could pass it to the trained AI model, which could decide, do we need to notify the police? Do we need to notify the community gardens or others, or to send the notifications in the apps? How could we detect the place where it happened? First of all, if it's installed from the phone, we can take the data from the phone. But if it's in the park or someone else, we got multiple panels which listens the area, and in the intersection of the places they're listening, we could tell you what the place without using GPS or tracking. Right now, we got open discussions with the cities. At least 2 of them are from Estonia. We are open for the cities, for the other cities if they're interested, and for the others who want to take part in the pilot project.
Thank you. Very interesting, different solution. Would it work? I don't know. But yeah, that's the pilot for. If you make the cities believe that it's doable, that not too many false cries or shouts there will be, that really you can find the right ones, why not?
Yeah.
That is doable without app. Yes, a quick question?
By fact, in some of the Caltech dormitories, they are using these sound sensors. How the security companies are reacting.
Okay, so it's somewhere a little bit in yours. Do you know that?
Yeah, I told about it, that there are sound sensors which are responding to gunshots and the glass break. So
okay.
yes, but specifically, we're not recording everything. We're just we're looking for the peak of distress when we scream.
Because I have worked in a security company, we have seen real situations. People drink, scream, and then somebody gets beaten up. So scream, camera, react.
Okay.
Yeah.
Okay, thank you. So inclusive night safety toolkit. Do we have? I can't pronounce your name right. So are you online?
Hello.
Yeah. Okay.
Just a
Yeah. Feel free
moment.
to share the screen and present.
Okay. Just a moment.
The green button for share. Coming?
Can you see this?
Yes, we see it. Yeah, go ahead.
Hello. My name is Li Hyeo Song. I'm an urban planning and inclusive city design researcher based in Seoul, South Korea. So the issue I focus on is women's safety in public spaces in Amsterdam. And this isn't something technology only can fix. I believe it really requires changes in the urban environment itself. So a woman's fear at night often comes from very specific spatial conditions, such as blind spots or low visibility, disconnected paths, and unclear layouts, and so on, etc. So instead of just detecting threats, the real goal is to prove the spatial and behavior environment that creates fear in the first place. So my work aims to turn technology detected risk into sustainable and proactive urban design interventions that the city can actually implement. So my solution aims for planning and design-centered innovation. Here we start by creating 3-dimensional pictures of urban risking using GIS technology. But we don't only rely on data alone. We involve a wide range of people like citizens or experts and city officials to really understand how women experience safety in the city. So we use 4 main methods to build this map. First, we use citizen participatory mapping. Second, we use data from experts and safety managers. Third, we use tech-based data collection using tools like drones or IoT sensors. And finally, we use existing public data. So the most important part is the citizen participation. So through safety walks or workshops and other engagement activities, we collect both qualitative and also quantitative data based on women's lived experiences. Then we combine that with the expert assessment and high precision spatial data from technology and publicly available data sets to create a rich and detailed picture of the city. So at phase 2, once all the data is collected, we transform it into a actionable diagnosed tool. So using existing research, we build a set of critical spatial indicators related to gender-based safety and defined a risk threshold. Then we identify areas that exceed the thresholds or show overlapping negative conditions. This allows us to capture types of unsafe environments that traditional crimes statistics often overlook. So we visualize all of this in a GIS-based spatial safety map. So in the end, we can clearly see women's avoidance patterns or unsafe segments, and ultimately the priority intervention areas where the cities need to focus. So using these priority areas identified in the map, we apply an inclusive night scan design approach. So our goal is to eliminate these blind spots and improve visibility, and propose low cost but high impact spatial changes. So instead of only relying on technical detection, we focus on urban design interventions that create structural and long-lasting safety for the city. So, so my goal is to combine urban planning and advanced technology to make Amsterdam a strong and practical model for a permanently safe public space. So the only one request that I have is that if it's possible, I would like to join the team with the City of Amsterdam and Teltech, and I believe like bringing these strengths together would allow us to build a well-rounded team and create public spaces that are more safer for women. So thank you.
Okay, thank you. I hope you listened also the other presentations for the same challenge, and feel free to contact the other teams if you see synergy. It seems that Denise also has a question to you concerning what is the innovation. What exactly is the innovation in your part? Can you very shortly answer?
It was for the previous one. It was for the guys for
okay.
doing acoustic sensory. But I have question for this one, if you don't mind. Basically, two questions. One, with your solution, I see one opposite thread that you will basically train other guys to understand what are the alternative routes. So women will avoid these non-safe areas by using some pre-specified routes where the danger might be just moved. Okay, we're waiting them here. That's one case. Second one, I'm not sure if all these analytics will provide evidence-based or some data for evidence-based decision making, but not sure if cities like Amsterdam or others we could change something significantly infrastructure-wise. It's rather where we could call reinforcement teams that will have more presence of them. And a third one, I'll give you example. We were analyzing the case of how could we ensure safety and security of Pride Parade participants in city of Kiev, which happens early. And one of the ideas was, okay, why don't we create some, let's say, hideouts, zones where people could just escape, just to the safe area. But if you come out with the OGDPR or the personal space area, then you could not identify them or assume person identity by their facial appearance, and you might still have some, let's say, intruders to those safe spaces. So I'll send you a request to LinkedIn. I would like to go deeply into your project. I think I'll find you some partners, probably across UK or USA, where there will be more the interest in your project. But we'll just need to reframe it a bit.
Yeah, thank you for the comments, and feel free to contact Denise from Kiev. We have the contacts if you don't, but probably they also on our homepage, so to discuss. But we have one more idea from Melita in this domain, so I will share her slides and she will present it.
Thanks, Külle. Seems that we could also do a sound stop here already.
Somewhere behind the corner. Not sure why. happened? No, it's not now. Correct.
It doesn't want to listen about the SafeCity anymore.
Too many ideas already because
Yeah,
okay, now I see.
too
it
over
here.
time. Is it shared?
Okay, I stop sharing and try once again and what's the button? Yeah. Now it's all okay. Go ahead.
I'll try to be brief because so many things have already been said, but approaching this from maybe a little bit different perspective as well. Yeah, my processes was a little bit different because I've been engaged a little bit with this topic from a female perspective, engaging in also our project this year about cities by night and walking my own city by night in spring this year. And it's more about how do I feel in my city at night. Not so much about whether I am safe or not, but I do not feel generally safe in different parts of my cities. As we can see from the map of Europe, it's very diverse, the feeling of safety of people in the cities. But there is a persistent gender gap. Women generally do not feel more unsafe in cities, and globally it is even bigger. What is causing, let's say, the unsafe feeling in cities for people? These are different interconnected factors. The most researched ones are the environmental ones that were mentioned already in the previous presentation, both the vegetation, lighting, visibility, signs of vandalism, connectivity, and so on. But there are many also individual and social factors that we cannot account of as a uniform, let's say, interconnected space. What I wanted to highlight and what also comes out in requests from cities in terms of the people living in cities that have said, okay, what does it make you feel safer in a city? Well, oftentimes seeing more police on the streets, but we cannot put policemen on every possible street, especially at night. Oftentimes they now have budget cuts and it's a little bit difficult. Regarding CCTV, the existing research shows mixed results. But I was thinking about the way how we could possibly improve it. Well, we are now living in the kind of age of emerging AI solutions, and also this is not something ultra new. But looking at different scenarios, for example, Amsterdam is more interested in looking at the outskirts of the city and especially of lonely biking paths that have poor visibility and are quite empty at the nighttime, but connect event venues with residential areas. Or other cities, for example, train stations is a very typical space that feels very unsafe specifically at night. In daytime it seems safe, but at night not. And then deploying AI CCTV surveillance that either sensor activated drone support or a static ones. And then proposing real-time human activity recognition algorithms and detection that could then alert the police, also put forward some warnings and maybe disturb the actual criminal act in the process. However, it all will not work if we do not co-design awareness raising and communication campaign with the public space users, so women in particular, but also other vulnerable groups. And what's also very important is people oftentimes are very concerned with data privacy these days and also responsible and ethical data governance. So I am basically one person with just an idea. I haven't had so much time to chase down researchers. I tried to talk with cities more. So I'm still waiting for feedback from Amsterdam if they would like to go through or forward with this or not. I'm also looking for an Estonian city or municipality, and good that they had a good collaboration with their local police enforcement. And from their development, I definitely need some IT people and some business people, ideally. If there are, of course, some technological partners that have cool AI cameras, we could also have them on board. That would be very convenient. Yeah, but thanks. I tried to be brief.
So thank you. We have now this, 5 ideas, I guess, were around this safety topic. So I hope to discuss with each other and with the cities and find some common things. We will take a 5-minute bio and coffee break, and then we will do the last session about the happy cities, people-centered cities. Okay, see you in 5 minutes.
Yes.
Hello, we started now, and Dirk is first, and if Davis is online, he can be the next one.
Yes.
Good. So, Dirk.
Splendid, splendid. Hello, everybody. Nice to be here. Urban Flow Intelligence System. This is about the Finnish challenge, managing seasonal and uneven flows of tourists by Liepāja, city in Latvia. It's a coastal tourism destination. Hello, Liepāja. I hope you are online also. It's nice to chat to you already. So, faces growing visitor numbers with highly seasonal peaks and lack of real-time data about where and when tourists move around the cities. So, this limits their ability to manage something, mobility solutions, and ensure safety, balanced tourism, residents' quality of life, and so on. So the problem is to achieve data ingestion and sensing from various data sources and sensors, Wi-Fi, Bluetooth, from tourist hotspots, beaches, parks, and other town. Privacy preserving computer vision counters like edge cameras, counting people, bikes, yes, mobile apps, public transport, parking, events, schedules, weather, and ship arrival data from cruise and ferries, and so on. And then, of course, to have the ability to have context management and analytics. So advanced analytics is needed, dashboards, decision support for city official, historical patterns of flows by time of day, season, event, KPIs like crowding index, dwell time, event attractions, beach occupancy, pedestrian bicycle, modal split, scenario exploration, what if analysis, and simulation is needed. So a detailed model of cities on which we can do simulations, what if analysis, and so forth. And not only for the stakeholders in the cities and the experts, it should also be launched to citizens and tourists via web portal and potentially mobile app, real-time pedestrian and bike heat maps, crowding aware recommendations, time slider to explore predicted flows for the next few hours, and accessibility-oriented views. So the solution, we need various components. We build on best of breed, open source, available products. So Fireware at the center for collecting the data from the sensors. Highly scalable platform from a huge EU project. Then Apache Kafka as a streamlining data platform to integrate data from the existing databases. And then on the analysis part for the simulation, we take Sumo, which is the best of breed in urban simulation, traffic simulation. And also we go for Urbanite, which is a 2025 project. That project was conducted. We need to see what the maturity of that is. But with Sumo alone, we can do a lot. So, and context management and analytics, both with Sumo and Urbanite. Context and management analytics rather the current concept. On the Urbanite side, we need to evaluate how far they are, but Sumo definitely is the best of breed. So here we have citizen tourist web portal. Yes, and we do not build from scratch, so that we also have resources to add beyond the state of the art some innovative AI. Here we have some pictures from Sumo. So in an innovative AI component beyond what Urbanite and Sumo offer individually, we need to add something, and we go for graph-based spatio-temporal deep learning engine, typically using PyTorch nowadays is leading for graph-based neural networks, which is then trained on past flow counts, exogenous factors, weather events, holidays, cruise arrival times, and so forth. And we would be able then to predict in real time crowding hotspots or also on the scale of multi-hour and next day's demand patterns. And we need to understand what the state of the art is and where we can contribute beyond, but all in service for the direct utilization in the city. So piloting all components needed for the solution are open source and no additional are required. And given our experience and the experience of our partners, we will achieve on the project very high level of technology readiness, system prototype demonstration and operational environment. So the solution will actually work for the city then at technology readiness level 7, and it can be used then. And based on that, for further sustainability of the solutions, we are of course glad then to partner in with the cities in making a startup later, but this needs to be developed then, these concepts. So yeah, the advantages of our solution, it is open source. We have best of breed Sumo, which from the German Aerospace Center. The Urbanite is a 2025 EU project. Here we need to see what the maturity is, but we could also have other components with further analysis like Apache Superset, for example. But it seemed to be a very good choice. Of course, we base on Kafka as a standard solution for data streaming, event-based data streaming. And we base on Fireware, which is a very large EU-funded project, widely used in the large communities tested and maintained for the sensor integration. And yeah, we are GDPR compliant. We have component architecture, so no silo. This means the solution is future-proof, extendable, and adaptive beyond what is achieved in the project. We will deliver a turnkey, tailored working solution. We have no vendor lock-in, no proprietary product lock-in, and we will have also latest AI innovations in our solution. Okay, very briefly, the team. I'm Dirk Draheim, Zeitig National Professor of Digital Society Technologies. I have currently a team of 10 associated researchers at Caltech and very reliable network of high-level experts in AI worldwide. And on that topic, we work very strongly together with Arun Kumar Sangaya from UNTech. He's UNTech Distinguished Professor. And we have proven capability to perform from previous projects, and which also reflects in our publications, Smart City Rule-Based Tools Recommendation, information retrieval for business recommenders, site planners, framework for unification of association with mining, online analytical processing and statistical reasoning, and Arun also with Basel Temple Online Review, portable consumer electronics and smart city tourism, and traffic flow control, and so on, just as examples.
Thank you.
Thank you very much, Külle.
Thank you.
It's a pleasure.
Yeah.
Thank you.
Now we can, yeah, I will help you.
Yeah, so the next one is Davis. Yeah.
Yes.
Transfer platform using cameras.
Okay, so you should be able to hear me and see the slides.
Yes.
Okay, perfect. Yes, so the name might be actually a bit misleading. But our background, we're the biggest telecommunications operator in Latvia, and that gives us an edge in this sort of solution because we can address the problem from a different approach to what others can do by installing sensors and similar other use cases. And we can do that using mobile device data, so IMSI. And this essentially allows us to see how people with their devices or SIM cards move across the cities. This is an example of Latvia. So there are almost 1 million mobile devices. So we would see also foreigners that are coming in and then detect how exactly they are moving. And this is somewhat how, for example, the density of movement could look like. But in addition to this, we get the data of where is the origin of this device. Say, for example, a German SIM card joins. So we get the data that around distributed by countries, where they are moving across the cities. But this is sort of the macro level of data that allows us to see the general movement in the country. But we can also dive in depth into more micro levels. So if we were talking about data moving city from city, then we can already also talk about movement from intersection to intersection. So this would be more events based, say seeing people in Liepāja beaches, seeing how crowded it is, and then how people move to from across the beach, and then similar instances. Yeah, and then what we see the biggest benefit of working with the researchers would be exploring different large data set simulation cases. So we gather the historic data of movement and simulate how, for example, one decision or another decision could influence the movement of people. And then if we look around city scope, then, for example, how we could influence the public transport system to facilitate that flow for the cities. But yeah, currently open to both different areas of researchers collaboration and cities as well. So yeah, let me know if you're interested, and let's discuss the potential.
Okay, thank you. The next one is Mikhail Derebnev, Proactive City Support System.
Do we have you?
Hello, do you hear me?
Are you online? Okay, so you will share your own slides, I guess, yeah? Okay, thank you.
Hello, my name is Mikhail Dernev from Caltech Viru College, and the challenge I'm addressing is simple and critical. Oops.
Can everybody hear Mikhail?
It's full screen now.
Yes, I'm here. Do you hear me?
Yep.
Okay. And the challenge is city services don't reach the right citizen at the right time, especially vulnerable groups who don't ask for help. This includes senior living alone, low-income families, new parents, socially isolated people, and residents with limited digital skills. All these services exist, but the people who need them the most never receive them. We believe the best smart city infrastructure is invisible. It should work silently in the background, matching the right citizen to the right service before they even ask. Our solution is a proactive city system. It adds a proactive AI-assisted layer on top of existing municipal or national systems, fully local, privacy-preserving, and designed for human-centered governance. Here is this infrastructure. Transform the city experience. First step, automated detection. Instead of waiting for application, our local AI analyzes pattern to detect needs, pattern of citizens. For example, it identifies a senior citizen who has stopped using public transport and at risk of social isolation. Second step, layer, orchestration. The workflow engine instantly checks available services like cultural workshops, social aid, or health, even health check, and match them to that special person's profile. And next step, proactive delivery. The system reach out via city app. Maybe each city have their own or other communication channel with personalized offer. We noticed you haven't been out lately. Here is a free ticket to a concert in your neighborhood. We move from a service provider to companion. We use infrastructure to rebuild social ties. We are ready to deploy this architecture. Phase 1 is pilot in Kohtla-Järve, where we will prove the technical stability of this engine with 35,000 residents. Phase 2 is global. We are already we are already aligned with Balcılar, Istanbul, a district of 350,000 people that has explicitly requested this solution to fight social exclusion. And we are inviting partners to join us, help us build the infrastructure that turn the city into a community. Thank you. And now I have a question to myself that I suspect you are also thinking, how do you plan to collect personalized data in such a difficult GDPR or KVKK environment? And honestly, I don't have full answer yet, but that is the point. We aim to find that answer through our research. Thank you.
Thank you, Mihail. The next speaker is Marko Mehtälä, Smart Citizen Engagement Platform. And Marko, are you there?
Yes, I'm here. Good afternoon.
Thank you.
Let me share my slides. Hey, good afternoon. So I'm Markku. I'm the founder of Superhood. Superhood is a tech startup in Helsinki, Finland, and we've been developing the technology within the Urban Tech Helsinki program. The background of the team, we've been building mobile technologies, mobile services for pretty much the past 25, 30 years already, since late 90s. The challenge, we all know that it's not really a technical challenge of how to get people to use the services. It's a discovery and communication channel. And the communications in today's world is changing pretty rapidly. People have moved into social media services, but even the social media services are changing really fast into a really algorithmic-driven entertainment systems. So the local community and local information is really getting lost in the noise. What we propose and what we built is a new type of social communications hub for all things local, which combines and really helps the whole local community and the ecosystem to benefit and come together, from the city services to consumers, to the local businesses and associations. Why we do this is that to get to people to actually use the services, they have to use them pretty much every day, or at least have a really frequent use of the services and technologies. So by combining these private sector services and the public sector services, we actually can make an environment where people stay and people can find and really get focused information about what's happening in their life in the local environment. And of course, the city services are really a big important factor in this everyday life if we present them in the right way. So we built Superhood, which became the hub for all things local. So it's already live in Finland, and we serve news and events and community tools for people all around Finland. There are private services and private companies and restaurants and so on, also part of these providing perks, and people can even purchase directly through Superhood the services. And we built the infrastructure is really a shared infrastructure for the whole world, actually, because every piece of information within Superhood has a location. So the location can be really an exact location that, hey, this is happening in this exact street corner, or it could be a fuzzy or an area location that, hey, this information concerns the whole city. So it's basically a polygon in the system that says that, hey, this information or this service is for the whole city. So we have the infrastructure ready. We are live in Finland. We have users in about 50 different cities and municipalities within Finland. So we have pretty good early experience on how to engage with users and how to keep users active in the platforms. And of course we are developing this forward all the time. But for this smart city challenge, what we are proposing is really a two-layer solution where Superhood, our existing solution, would be the social and community layer for people to communicate and engage with their local community and with the private sector in the city. But in the project, we would develop together with Taltech an AI-driven personalization layer, something exactly what Michael was describing, where the AI-driven personalization layer takes data from an input from the community layer and from the city services, and then can drive the usage of the city services. So this AI-driven personalization layer would be hosted by the city and managed by the city, whereas the social and community layer would be managed and hosted by Superhood. And Superhood would be providing support and go-to-market activities to engage with the local businesses and associations and so on. The AI-driven personalization layer can also support other apps and other channels to activate people, because we know that it takes time for people to actually get to use the app. So for this, we are already in touch and discussing with a few cities. We're welcome to provide more information and get more closer with cities. And then, of course, we're looking for collaboration with Taltech to actually work on this AI personalization layer. So here's my contact details. So please be in touch if this is interesting. Thank you.
Thank you, Marco. Daria and personalized citizen services platform. Daria.
Thank you so much. I really appreciate the invitation. Let me please share my screen. Can you see it well?
Not yet.
Oh, how interesting. Should be on. 1 second. And now?
Yes, we can see it.
Fantastic.
Cities have never offered more, yet people have never felt more alone. What if your city could speak to you personally every single day? My name is Daria. I'm CEO of IT software development companies. For years, my team and I has developed AI that matches people on dating apps, on healthcare applications, and even connected founders to investors. What we learned from this is that people engaged much better with something that felt like it was made specifically for them. Today, we're bringing the same level of personalization to cities, so cities can finally connect with the right services at the right moment. This is how we turn cities from places where people live into places they love. Cities offer so much, but citizens rarely see it or use it. We imagine the city as a great match, something you can truly connect with. Our idea is simple: bring the excitement of personal connection into your city. Even in the busiest cities, people feel invisible. 1 in 4 citizens struggles with loneliness. We walk past hundreds of opportunities to connect every day, and we miss them. Not because cities lack services, quite the opposite, but because people don't know how to find them, how to fit in, who to go with, and share the experiences. This is the gap we solve with personalization. We built an AI that talks to citizens every day. Just like a successful dating app, it matches their mood, interest, and habit. Our system learns each citizen profile and gently matches them to city events, to classes, to social group, to local initiatives, to neighborhoods, and to neighbors. So you can go and share events and experiences together. Your city reaches out first at the right moment. And this is where the magic happens. People feel seen, they discover new things, they met others. City programs get full, engagement grows, and suddenly the city feels like home. We want higher participations for your program, stronger communities, and happier citizens. Our solution is easily adaptable and can be built in any city infrastructure, which is very easy to implement, build, scale, and commercialize. I will share the demo of our AI with each and every one of you. Please drop me your contact details. And today I invite both cities and researchers to work with us to bring your brilliant minds and to help our software developers get to learn your city. Any questions? I'm happy to take.
Questions? Thank you, Daria. Let's move on with Mohammad, an AI-powered cities and engagement platform.
Hello.
Hello. You can share your slides.
Sure. Let me share my screen. So, hi again. I am Mohammed, founder of Hubcast. Actually, I wanted to tell you one imaginary situation which is challenging for most of cities. Met Aisha. She's 73, living alone in Bajalar municipality. There have been lots of events and classes in her cities, but she cannot hear about them because she rely only on general announcement. 740,000 people, more than 100 services, and right information never reach the right person at the right time. So the challenge is that cities cannot deliver the right services to the citizen. And we are solving these delivery services in order to fill this gap by our core platform, which is Hubcast. As you know, there are lots of different challenges and problems: low adoption of digital services, generic commission fail, fragmented citizen profile, and isolated communication between different stakeholders, and reactive instead of proactive. Citizens are reactive. And this is our solution. This is where Hubcast comes in. Privacy compliant AI personalization layer. City data flows to unify profile, processes by AI engine, and delivered by a personal challenge, and then it is ready to create value for stakeholders, citizens, and municipalities. Our solution has 4 pillars: a unified profile, which can gather data from citizen, AI communication to provide right message at the right time, at the right place, and zero disruption, working in the existing municipalities, and privacy first solution. So why us? Why Hubcast? Actually, we have been in IoT and building management system more than 10 years. We have proven different AI solution. We have been aligned with smart city need, and we provide privacy first design. And what make us different from others? We close the citizen gap by providing AI-powered personalization, which is our core competitive advantage. And actually, we focus on bachelor municipalities, and we consider them as potential strategic partner to co-create a pilot to provide and satisfy their need. We are in negotiation for collaboration with a well-known technology provider in order to provide a better solution. We are looking for research collaboration with Caltech, and we are ready to Estonia integration compatible with X-Row. And they have been many opportunity, not only limited to municipalities, for example, real estate developer, university campuses. And this is our partnership invitation. We can help city to be first mover in the next generation of digital governance. So we are seeking a partner in Estonia and other European city, and consider Bachelor as our strategic partner. Moreover, we are welcome to any other researcher in related field. And again, I will be in Estonia in January, so we can meet in person and have a chat. Thank you.
Thank you. Victoria, the floor is yours on...
Yeah, hello, Anneli. I'll take this presentation. I'll share.
Simona.
So I guess you can see the presentation. So hello, everyone. I'm Simone, and I'm presenting ConciergeAI, Find Your Next Thing, together with Victoria, that you met previously in another presentation. And so we try with this idea to respond to the challenges as well as some previous presentations of Bachelor in Turkey, and also from the Caltech campus in the field of campuses fostering creative economy, and also about services that don't reach the right people at the right moment again. So what are the problems here? Yeah, we already seen that there is a field of scattered information across different platforms, usually both in neighborhoods in the city and in campuses. Information overload the end user, and also the research of information overload the end users, which is a problem. There are many underused spaces and services, both in campuses and neighborhoods, which are not optimized, or where there are no ideas of what to do with them. There is a limited feedback from part of the users, and users, especially real time, which leads to low engagement at the end towards the living space, actually. And of course, this leads to limited and uncertain short and long-term planning actions to be taken from the campus owners or neighborhoods and municipalities. So the idea, it's a conversational AI assistant, which is personalized. It's embedded again in existing applications, both taking inspirations from what Bachelor is having, and also, for instance, Caltech campus application, and a backend machine learning-based analysis tool and dashboard. So how these work? The end user will get AI and profile-based recommendations for events, spaces, and services within the campus or the neighborhood. The application itself will track timestamped anonymized data about space event usage, attendance, but also people flow and density within the environments within the spaces of the campus or the neighborhood. And at the same time, the AI assistant, so the concierge, will ask real-time microfeedback to understand the user needs, what they feel, how they feel about each space in each environment, or what are their preferences there. So the idea is to have like a flow of AI agent asking some questions, some users expressing interest, and then the AI suggests opportunities, while then the user will act something out within the campus or the neighborhood and will give feedback. And the feedback will be personalized based on the preferences and previous answers and to questions, actually. And based on this data and data analysis, cities will be able to, cities and campuses, to adjust services and spaces based on this data itself. So the innovation here is having this conversational AI, which is personalized, is a proactive personalization, a continuous feedback from the end users to have real-time planning insights. This what actually leads to and actually makes visibility of available spaces, meeting points, which are important both in campuses, in urban contexts and neighborhoods, of non-conventional events, or what people would actually not choose to go, for instance, to have a continuous user feedback about spaces, events, and services, and to have a perception of the space quality from the point of view of the end user. This visibility, the visibility of this data, will allow some spontaneous organization and gatherings based actually on these non-conventional events, meeting points, or even just where people meet along the path to lunch or somewhere else, or where they have coffee break, and cultural exchange, of course. It will allow programming changes and services updates, spatial modification, and actually to have a measurable impact, which can be measured by the feedback, by the continuous feedback. And this can actually scale up. So I'm focusing more now on the design maybe level, from a small scale pop-up and temporary solution, which might respond to initial testing and space usage information, trends, user preferences, but also where people actually hang around in the spaces itself, to a more optimized, let's say, and medium long-term scaled up intervention in campuses or neighborhoods. So basically to have enhancing the well-being of the user, the citizens and end user of a campus, enhance their feeling of ownership and agency within the environment itself, and to have at the end of the story AI-mediated participatory process through continuous feedback. So the piloting, we would need like or permission to use databases, integration of services, activities, space management systems, and anonymized data, behavioral and geolocated data, and also like from part of municipality and campus, like internal IT team that would help us supporting data integration. So thanks a lot for listening. You can contact us, and I guess there are some quite interesting overlaps from the previous presentation. So feel free to drop an email and we can discuss. Thanks a lot.
Thank you, Simona. The next speaker is Patricia, and Integrated Scalable City Platform.
Hello, that's me, Franz, actually.
Okay.
Sharing a screen, not Patricia. Patricia is working with me. Hello, thank you for having me this afternoon. My name is Franz. I'm the CEO and founder of Innowise. And I want to show you how Innowise can help cities to become smarter by turning their existing data into clear real-time insights. You can see my screen, right?
We can see you.
You can see, but you don't see my screen?
No, we can see you only.
Now it's coming.
Do you see it right? Now?
Yeah, now yes.
Okay, you see the PowerPoint, right?
Yes.
Yeah, perfect. So as I said, I would like to show you how InnoWise helps cities to become smarter by turning their existing data into clear real-time insights. So we focus on the challenge the city services do not reach right citizens at right time. We face the problem that cities today collect more data than ever, but this data is stored in separate systems that don't communicate with each other. So as a result, there is no real-time unified view of what is happening in public spaces, in infrastructure, for instance, or in any other environment. So we at InnoWise, we solve this gap by bringing everything together into one clear operational picture. So what is InnoWise? So we are a smart city IoT platform which was built to connect and store all municipal data, for instance, like sensor data, like infrastructure, like energy data, like mobility information, environmental measurements, or any cameras. And then what we do is we visualize these data on customizable dashboards. And of course, we do visualization and analytics about this data. So what does the InnoWise landscape look like? So we have different connectors. We are a cloud-based system. So the idea is that the cities should not have to replace what already exists and what already works. So we have standardized interfaces to REST, MQTT, to GIS, to different BIM systems to integrate this data in our InnoWise cloud. And once connected, the city gets real-time awareness across all domains like air quality, for instance, noise, temperature, occupancy of public spaces, pedestrian flows, energy consumptions, and any status of critical assets. What we also have is like an advanced alerting system. So this gives your city a clear real-time view of what is happening and where it is happening. So InnoWise integrates an advanced alerting system if energy, for instance, suddenly spikes, if noise level rises in areas where it should be quiet, or an area becomes overcrowded. And so the city gets informed and can act immediately, send police or security to solve the problem. So this speeds up the response time and helps operations run more safely and efficiently. And we are professionalized in digital twins. So InnoWise is designed to grow into a full digital twin. We support different 3D modeling systems to visualize either buildings or 3D maps of cities. It becomes, I guess, the foundation for more advanced services, including risk assessments, mobility optimizations, and also for a lot of more digital services that could be offered to citizens. We are known for fast and easy setup. So InnoWise is easy to install. We don't start from isolated use cases. We start from physical cities itself. So we connect to the real-time sensors, the real assets, or the real-time, and give a real-time visibility. We can connect to any data that is existing and import it to our cloud. InnoWise connects the physical layer and the digital layer in one place. And InnoWise will not replace an existing system. That's very important. It amplifies it. It turns fragmented data into real-time intelligence, and this causes meaningful impact for citizens. What we are looking for, of course, for partner cities, like municipalities interested in testing and scaling real-time urban data solutions. We are looking for TALTECH researchers, especially to develop more advanced digital twins, to analyze data sciences, and to give sustainable mobility. And of course, we're looking also for technical partners to integrate sensors, data collectors, and whatever is needed to provide a full digital twin of cities. So thank you very much for listening. If you have any questions, please let me know. And here are my contact details.
Yes, thank you.
Thank you.
The next speaker is Kamran, and the topic is AI-powered city app.
Yeah. Okay. Okay. Just a second. That's the right one, yeah?
Yeah, exactly.
I will share it as well and the online ones will also see.
So, hello everyone. I guess the challenge is city services not reaching right citizens is a very hot topic. Already I'm seventh proposer for the solution. Well, I listened to all the proposers and I would say that we all have quite similar or in some ways the same approach. This is the platform which is AI powered, which will help to analyze existing data and also collect the data which will be gathered from the users, and users are citizens or tourists of the city. So in our solution, we offer, as everyone did, platform, AI platform, SaaS. The key capacities of our offer is the platform will have two phases, let's say. One phase for the users, citizens or tourists, the application side. And the second phase is there for the governance, the platform, admin panel, let's say. So for citizens, it means that it will be all in one platform where they can see the news, ongoing renovation work, closures of the roads, hazard reports, I don't know. Even in the future, it's possible to integrate the public transport map, ticketing, purchase, even like the government can sell the, I don't know, t-shirts, flags, whatever they can sell to the citizens. And it will be one platform. It will help citizens to get rid of several social media platforms where they can, right now citizens spend time to find some information. So most of the time the information is kind of get lost on the way, and the right person don't get it. So this system will help in that way. And also it will be personalized, based that all users will be analyzed by AI and all users will receive time-to-time notifications, emails, SMS, whatever they prefer, the information related to their preferences. At the same time, as it is interactive, comparing with current solutions as classic website or something extra, here government can, municipalities can send different notifications, reports, run surveys, I don't know, announce some kind of new events, what they have, and track the activity of the users, how the citizens or tourists react, how they click, when they click, what they prefer, what they don't prefer, what they suggest, what they are interested in. And also it will be both way interactive, that the citizens can also report to the city, municipality, some kind of errors, problems, I don't know, on some road, some kind of bulb is broken, so they can just quickly report, and the city will quickly take an action and fix it. Of course, data is nowadays the most precise, I would say, investment for everyone already. So the data will be encrypted. It will be based on the, I would say, based on the international and local regulations. It will be handled by the rules. By the way, sorry. Of course, we are planning to make scalable SaaS platform. Of course, some cities already have application, like Valular municipality already they have application, and also they pay in Latvia. They also have a quite good application, but I believe it's not AI powered. It's just good application. Let's call it. So in our case, we can help. Not only we will not replace their application, we can also provide plugins in that way for already cities which already have application. So a little bit about us. Our current team consists of 2 people, me, project manager, Kamran, and our software developer, Alperen. By the way, he is from Turkey, and I guess with Bağcılar municipality, he will have a great connection, and the easiest way to communicate is the native language. Well, we already built a solo-made SaaS platform, which is quite similar to what we are offering right now, but it's focused on the beauty industry. It is a customized, personalized application for beauty salons where they can, AI powered, of course, where they can track their clients' actions, offer their personalized suggestions, needs, and so on. believe that with this experience, we are capable to make in very short time the pilot version for this challenge. So what we are looking for? We are looking for teammates, of course. We are looking, first of all, for cities which are ready to take a very interesting role with us, where they are open to share their, of course, under some regulations, the data, what they already have. So more cities means more data, which means better product we will have at the end. So that's why we are looking for cities, for municipalities who want to take a part in this journey. At the same time, we are looking for tech researchers who are mainly focused on AI, machine learning, and predictive analytics. But also at the end, I would like to say I listened all proposed solutions, and they have quite interesting approach as well. So in most cases, we have similarities, and we will be open to discuss the possibilities, collaborate together. Thank you.
Thank you.
If you have any questions, go ahead.
I think we have to move to our next presenter, who is talking about transparent infrastructure investment platform, and Shahab. The floor is yours if you're here or there.
Do we have you online?
Okay. Transparent infrastructure investment platform. Nope.
If not, we can skip that.
Let's move on to AI Urban Planning Assistant by Mirko and Martino.
Yes, can you see me? And can you hear me?
See you.
Okay, I'm Martino, of course. Mirko wasn't able to come up. So I'm sharing my screen.
No? We see you?
Okay.
Yeah, it's coming.
You see it?
Yeah.
Okay. So good afternoon. I'm Martino Petropoli. I'm a PhD candidate in architecture, and I'm speaking for the Urbia team. We're a scientific alliance, complex systems physics from Bologna University, engineering from Taltech, and supercomputing from Cineca, Italy's largest cluster. We're bringing urban intelligence out of the labs. Look at this image. These dots on the left are your city's data today. Sensors, PDFs, maps, satellite images, street view photos. They exist, but isolated. A city with disconnected data is not smart. It's just an expensive archive. Urban intelligence means connecting these dots. How? By moving from unstructured data, bureaucratic and physical chaos, to knowledge that drives decisions. It means unlocking hidden knowledge. We do it with the M-Cube framework, that is multi-layer, multi-scale, and multimodal. We don't slice the city. Urbia reads regulations, physical space, and evolution over time, all at once. This is the innovation. Current dashboards see numbers and coordinates. Urbia sees connections. It understands that a regulation constrains a building and influences its future maintenance. We unite words, space, and time into one reasoning engine. It's data fusion. Urbia engine uses language models and vision AI to break down silos. The platform ingests different data types, and AI agents correlate them to simulate scenarios. It's a glass box. It's transparent and verifiable. Let's see it in action. The interface is basically a chatbot. It's easy to use, yet powerful. Take Tallinn, for instance. The problem, systems that don't talk to each other. The user input is find dangerous intersection for the 2025 budget. Urbia reads police reports and budget files, and the result are 3 specific intersections. Or on a smaller scale, take, for instance, Castenaso, which is a small town, a much smaller town near Bologna, 1/10 of Tallinn, for instance. The challenge is autonomous mobility. We ask, is Via Roma ready for autonomous buses? Urbia checks scans and drainage maps, and the answer is no. 3 sensors needed, and flood risk at kilometer 2. Same engine on a different scale. So to all the cities listening, you have the data, you need the answers, and Urbia fills this gap. So for more information, reach out, and thank you very much for your attention.
Thank you. The next speaker is Anniki. Or Helen, I'm sorry. Helen is here, Adaptive Unit Mobility Footprint Analytics.
Second, I will share the slide. Doesn't work.
Good afternoon. My name is Helen Sooveli-Sepping, and I'm here together with my colleague Anniki Puura. She is following us through Zoom. We would like to present a real solution for something that is highly needed for today for cities today, and we have called it as Adaptive Unit Mobility Footprint Analytics. We addressed the first challenge, empowering citizens to change mobility. No, I can't. The mobility habits, yes, and we acknowledge that the change of mobility behavior starts firstly from infrastructure, that the infrastructure is there, and then secondly, we have to zoom in the city in order to make the behavioral change happen, and that we need to do to a neighborhood level. So our suggestion is that we work on the neighborhood level instead of the whole city level, since there have been many plans, strategies, tens of years in order to change the mobility mobility patterns in the city, and they have not been working well. So we see the need to zoom in, and we do that by local level action and empowerment of the citizens. This solution that we are defending here right now is resilience-proof response to city level decarbonization efforts in European Union, and we know that the European regulations would demand us to think of solutions that we are proposing right now. We are working towards a sort of integrated user-friendly design for positive energy district framework, meaning that not only the model we are suggesting is innovative, but it should be user-friendly and transparent as well. So what are we doing? Put it very simply, we would like to integrate two data. The data of mobility and the data of the buildings. And by having these two data integrated, we have simpler ways of understanding how to decarbonize the district or the neighborhood. We have had good feedback already from different cities and districts from Europe. And we have right now been working together with Hundipea, the real estate development in Tallinn. And we also see one of the places to work in TalTech campus. The university campuses are here also understood as a neighborhood. We see the need of working together with a clearly interdisciplinary team, meaning that we would also like to have a service designer working with us, so that we understand the journey of the data and the journey of the solution to be user-friendly. We are expecting responses from smaller cities or municipalities, both in Estonia but also outside Estonia. And we see that there is also a strong additional value in our innovation proposal. And there are two values. One of them is being that it's a living lab, in the sense that we would like to use the data and the building up this innovation by using it as an example in the classrooms. That means that it's a teaching project. We would like to involve the future engineers and service designers, the students in the project. And secondly, we see it important that this solution itself is a low carbon tool. That means that we will be measuring the carbon footprint of the innovation itself, as it should be monitored while we are doing it, and then the solution itself. That's all from my side and from IT side. Thank you.
Thank you, Helen and Annika. We have two more left. The next one is Irina or Milan, and the subject is gamified and safer school journeys.
Hello, everyone.
Hello.
We are online, so it would take us just a minute to share our screen. Or perhaps you need to give us some...
The others have managed to share without any permission.
Okay.
Okay, so I hope you can share. Do you see the button?
Yeah.
Okay.
Unfortunately, I will have to exit the Zoom and then join in again.
Okay, we do the second presentation then first, and you will come then the last one. Okay, good. Okay, yes, we have then Kim Lylykangas with the second solution for. I will share it also online. Second. Now it also stopped for me. Too many open. No, maybe we can say this way. No, this one. No, which one is yours? This one.
Yeah.
This one as well, yeah. Yes. Or did you see? Yeah, okay, they see it. Yeah, they will see it. Okay, good.
Thank you. So good afternoon. My name is Kimmo Lylykangas. I'm professor of architecture and here in Taltek. And I'm presenting this solution with Professor Antti Ahlava, who is joining us online. And we are representing a researcher team from Taltek, University of Helsinki, and Aalto University, proposing a solution to the challenge about campuses fostering the creative economy, based on the observational notion that the current approaches to campus development are insufficient to make most of the potential. Our solution proposes a new campus consulting field and a digital playbook, which we consider it should be interesting for the cities, as it is about how cities could benefit more of university campuses, business campuses, and creative industries campuses, presence of these organizations in the city. Our solution includes components such as digital playbook, participatory design processes aiming at creative ecosystem solution where we connect learning, research, living, and creative economy to advance local innovation goals. In Taldek's case, Estonia strategic innovation goals. And the solution here is called the Porous campus model, which is represented here by this image. Open, social, and physically permeable realms that extend in the surrounding areas. The researcher team here, you can see some of the names here is quite distinguished team of researchers, including Professor Luka Mora, Epi Tohvri, and Sami Moisio from University of Helsinki. And we believe that we can really address this question with high quality solutions. And if Antti, you wish to address this topic with a couple of words online, you are most welcome to join in. We know that you have quite a track record in campus development in Aalto University. So if you wish to share something at the end of my presentation, please feel free to open the microphone and complement to what I presented.
Yes, thank you very much, Kimmo. Maybe I could add this, that it is clear that knowledge-intensive and creative fields are really crucial for both economic and cultural growth of cities, but it is also evident that the potential which they have for urban development has not been researched and then utilized, that we don't have enough like a learning from benchmarks which are already made. And our idea is to develop both digital and tangible tools, as well as a sort of new consulting field, new consulting companies to offer this type of service which facilitates this.
Yeah, and anyone interested, please feel free to contact either me or Antti. You can see the contact information here on the last slide. Thanks.
Thank you. Thank you. So do we have now, Irina, are you now online and can share? Yeah, it's coming. Enter full screen mode, and we don't hear you now, but we see a screen very nicely. Yeah, can you switch the microphone on? We don't hear you. We see the slides nicely. We can have either slides or voice, not both at the same time.
Technology has given up on us.
Yeah, definitely. I will have to ask Milan, who is together with me today, to try to figure out this one. So thank you everybody for the patience. And today we're gonna talk about safer and smarter mobility, because every teacher, were you able to see our screens?
No, we can only see you, but not the slides.
That's interesting.
Now we see the
slides.
Okay.
You have to add the full screen mode as well.
I'm sorry?
Full screen, please.
Yeah, push this button.
Yeah,
good.
Okay, so hello everybody. My name is Irina. I'm co-founder at Tembo Solutions. So today I'm here with our product owner, Milen, and we're going to talk about safer and smarter school mobility. So everybody is aware that early morning is chaotic. Every student, every teacher, every parent goes through a little madness. So today we really want to focus on what we can do about it, not just participate in the traffic problem, but also be part of the solution. So Milen.
Yeah, school zones face the same problem everywhere. Too many cars trying to get as close as possible to the school entrance, which of course leads to safety risk that no speed bumps can solve. Czechia has already tried traditional tools like speed bumps and others, but habits remain unchanged because the key ingredients are missing. There are no real-time picture of how kids actually travel, no rewards if something is different, or any other incentive to motivate them and help them be pedestrians or cycle on their own, and no monitoring system that lets the city steer daily mobility. And that's the gap we are addressing. WeRide today provides the behavior layer that the city doesn't have. For children, the school trip becomes like a game. They earn badges, class challenges, of course, friendly competition that makes walking and cycling feel more childish, feel more natural to them. For parents, the community report hazard and near misses, forming a life safety map that builds trust in the routes their kids use. And for the municipality, the platform captures real behaviors every morning: congestion patterns, preferred routes, dangerous crossing, modal shifts. This creates a continuous feedback loop, motivate behavior, measure what happened, and improve the environment with the data instead of guesswork.
So,
Sure. Yeah, most of the existing digital tools on the market were never designed for the school journeys. Fitness apps, for example, focus on athletic performance, reporting platforms that gather one-off complaints that rarely leads to a deep understanding of what actually causes it. And we would like to bridge that divide by creating a unified layer, a real-time, hyper-local safety information paired with behavior activation engine built specifically for children, parents, and of course with together with schools. Our approach isn't hypothetical. On the contrary, the underlying technology that we've been modeling and building has already been proven itself in multiple mobility campaigns that we had, for example, with bike work on adults. But where we've seen how gamification incentives and live data can shift that habits in scale. What we would do in this program is to refine these models, this framework for school context, designing challenges that resonate with children, building trust with parents through transparent data practices, and shaping tools that municipalities can depend on. And of course, privacy remains central. Families maintain control over their data, and the system is engineered to work safely, even in sensitive school zones. And if our pilot succeed, we are ready to extend this platform to interface with emerging smart infrastructure like intelligent bike parking, sensor support crossing, and other city systems. We would like to take this. Next slide. Yeah, and we would like to see this as a living lab where real behavior meets academic expertise. The platform provides rich mobility data. Its routes, its hazard, personal achievements, statistics, travel statistics, and some behavior patterns that we found so far. We are looking for research expertise from Toltech, and especially in theory of plant behavior, gamification theory, and causal inference. And we do believe that together we can test what actually drives long-term behavior change and generates results that the cities, the municipalities across, not only in Estonia, but also in other European cities can rely on. It's a genuine co-creation where practice meets science. Yeah. And by combining this behavior, motivational, real-time safety insights, and city-level analytics, we can reduce morning congestion, give children independence by reassuring parents, and let cities act on evidence rather than intuition. We are inviting not only Czechia, but also other cities in Estonia, and not only, to join this pilot and shape a model of school mobility that can scale everywhere. Together, we can turn the morning rush into a daily routine that is safer, funnier, calmer, and of course, healthier for everyone. Thank you.
Thank you. Thanks everyone who stayed with us for this very, very long time. 47 different solutions were proposed. So really, dear cities who are still aligned, please look at the challenges and contact all the contacts available at our homepage, contact the idea proposers, and yes, discuss the opportunity to discuss the ideas, and vice versa, dear researchers, contact the cities from Estonia and from other countries. You need two pilots in two different cities. So contact them, have the online meetings or in Estonia face-to-face meetings, and discuss how it can be done in practice. If we had several ideas for one challenge, consider joining forces if it makes sense. And yes, February 27 is the next deadline. If you have still questions, feel free to contact me and ask. And if you need to listen to my presentation in the morning, that will be also available. So if you don't want to know about the process. Thank you. It was a great day with you.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Thank
Thanks.
you. Goodbye.